Hi, my name is Jonathan. On this session, I'd like to go through the basic configuration and setup of Stackflowos. Computing history has shown that open multi-layer hardware and software stacks encourage innovation and bring costs down. Towards this goal, I have Stack an easy-to-use SDN starter kit and nicknamed it Stackflowos, designed to provide everything you need to get your SDN lab up and running in few minutes. I have taken the guesswork out of deploying SDN by integrating a controller, the popular Kuaga open source routing suite, and the low-level vendor-independent OpenFlow interface OVS, which has led to dramatic stuff like SDN Stackflowos. The goal is to assist you to get started as quick as possible with deploying of SDN-enabled network. As you progress down the path of SDN, one thing that is clear is that there are no cookie-cutter deployment. Everyone has a different application, a different user case, and a different rate of adoption. I believe that the network should be flexible and easy enough to help anyone on their journey. With Stackflowos networking, you get the flexibility and granularity of flow-based networking policy on the same device that's running traditional layer 2, layer 3 protocol for efficient packet forwarding. Stackflowos networking user can use OpenFlow, fine-tune the switching fib or the router read table in a switch. This allows users to inject the OpenFlow rules for specific application and the policies, while also preserving the networking topology that's built on tiered and true layer 2 and layer 3 protocols. As you may or may not know that every networking device we use today has 3 planes. Let's zoom in. The data plane where actual forwarding is done, and this is where ASCIIs are sitting or any other silicon you're using to quickly forward the traffic from input to output interface. The forwarding table has to be programmed through the control plane, which is where various protocols like OSPF, BGP, ISIS, RIP are sitting. They exchange information with the neighbor and figure out the topology of the network and figure out the best path to a certain destination will be, and then install that information on the routing table. The best information on the routing table goes into the forwarding table. On top of everything, we have the management of the policy, where we do the configuration and we can use CLI, GUI, API. It doesn't matter, to monitor the device, to see the parameter of the device, and to adjust the operation of the control plane protocol. In an OpenFlow based network, there is a physical separation between the control plane and the forwarding plane. The idea is that OpenFlow controller sends forwarding information data direct to an OpenFlow client in the device. The device firmware loads that to the forwarding path. So now you have taken all of the complexity around the things in the network equipment, the OSPF, the BGP, you name it, all sort of stuff to the OpenFlow controller. In this situation, the only firmware or software on the device is the cheap firmware enough to run the fib or the DCAM memories and to run simple device management function, that is to present the CLI, to run the flash. All the complexity around generating the forwarding table is extracted away to external controller. It's also possible that the device could still maintain protocols and have OpenFlow support. So in the world where complex software exists and run STP, OSPF, BGP, doesn't have to replace this. It's not like OpenFlow necessarily replace all the software that goes on a network. OpenFlow could be an addition too, so that it's RIP could still be loading data into the fib, so could OpenFlow loading data into the fib. And this is a transition strategy for the future. This model is better for the enterprise business. They have multiple stream, multiple model, multiple flow, multiple protocol, multiple location, and control the environment to some extent. And this is where this lab will focus on. To recap, regardless of the architecture you are using, as we have seen in the previous slides, if the devices are properly configured to communicate with the OpenFlow controller, the device will establish an OpenFlow session with the controller. As soon as the OpenFlow session are established, the controller will run the topology discover and build a model for the network. This is almost identical to how OSPF works, only you have a topology in one centralized place. It's not in every single forwarding entity. Then, for example, when you configure OpenFlow controller discover, there is a host B on the right hand side. The controller would enter that information on a network topology model based on the topology and the connectivity information like host B is on the right hand side, it will compute the forwarding entries that need to be downloaded on every single device, and then it will download those forwarding entries. The end result will be almost identical to what a routing protocol will give you. The cross-flow mode is what I call the mode of operation using both OpenFlow and Layer 2, Layer 3 on the same switch. Every port in the switch is either a legacy or a cross-flow port. A legacy port is using traditional Layer 2, Layer 3, while cross-flow port can be controlled by OpenFlow. All the typical obvious command can be used in cross-flow mode, either local via obvious command or via SDN controller using OpenFlow and OVSDB. Cross-flow port modes can be summarized as follows. Cross-flow mode off. This port is controlled by the switch local Stackflowos control plane. All broadcasts turn on and auto lane turn on. Packet forwarding by lookup at the TCAM or the FIB. Stackflowos controls the TCAM and the FIB completely. Cross-flow mode on and local controller off. The port is totally controlled by SDN controller. All broadcasts turn off and auto lane turn off. Packet forward by looking up at the TCAM or the FIB. TCAM and FIB managed by SDN controller. Cross-flow mode on, local controller on. The port is controlled by the switch local Stackflowos control plane. All broadcasts turn on and auto lane turn on. User or a controller can add flows in the TCAM to control traffic. Benefit of cross-flow networking: save money by reducing capex. With cross-flow, you don't have to purchase a different set of networking equipment for your OpenFlow implementation. Save time by reducing the complexity of different modes of operation between Layer 2, Layer 3, and OpenFlow. Deliver business logic and policy into the network by simplifying the integration of SDN into your network. Let's go ahead and take a look at the big picture as to where we will find SDN deployment. The nature of work is changing. We are no longer content to be confined to our desk, chained to a PC. Employees want the freedom to work from anywhere, at any time, from a variety of devices: laptops, home computer, tablets, mobile phones. Moreover, we are a global workforce constantly collaborating with not just the people in the office but also with customers and partners beyond the firewall. Applications are mobile and integrated. We can take an address for an email, plot it on a map, find the phone number, and make a reservation, all in a single seamless experience. Cloud computing is removing the barrier to storing and retrieving data, making the data far more useful with the context of the user needs. Cloud computing is a model for enabling convenient on-demand network access to share pool of configurable computer resources. For example, network servers, storage, application, and services that can be rapidly provisioned and released with minimum management effort or service provider interaction. Cloud computing customers do not own the physical infrastructure. Cloud computing users avoid capital expenditure on hardware, software, and services when they pay a provider only for what they use. Low shared infrastructure and cost, low management overhead, and immediate access to broad range of applications. Software as a service is a mode of software deployment where the software applications are provided to the customer as a service. Platform as a service deliver a computer platform where the developers can develop their own application. Infrastructure as a service delivers computer infrastructure, a platform virtualization environment as a service, rather than purchasing servers, software, data center space, or network equipment. Client instead buy those resources as full outsourced services. Let's take a look at service delivery and the software-defined environment. A cloud architect will be the one who can go out and detect the patterns and see what type of application support different environment need. So they define security parameter, define storage parameter, and come up with a template that are going to be used to provide a solution to the user's problem. Once they come up with those templates, they are going to be published and managed in a central location, and this is where we are going to make them available for different users for different costs, and we can decide who gets to buy these services, who is not going to buy these services, what is going to cost, and how are we going to change them. So now when a user wants to get these resources, they don't have to talk to anybody. They simply go out on a site, make few mouse click, and immediately they get access to all the resources. Let's assume that we are the service provider and we have taken care of the premises, the power, and the cooling. Let's focus on the server and networking and see how we are going to handle that on cost-effective manner. Talking of bringing down cost, we are going to use the white boxes. We are moving away from a vertical integrated system where all the components and tools are provided by one vendor to a horizontal market where layers are provided by individual vendors and people specialize on each of these functions. Taking a closer look at the white boxes, these are some of the key players in the industry, names that you may not have heard of, but they have a lot of manufacturing power, from iPod to a server that you may have in your data center today. Taking the manufacturing power and help to commoditize this technology so it's robust yet cost effective. On the networking side, we see the same direction. For years, white boxes switches have been available. Web properties giants like Google, Amazon, Microsoft all pioneered to using these white boxes switches. Now we are seeing a movement towards mainstream networking looking at this particular technology. The whole idea of open networking is to parallel the server world from the white box to abstraction software to Linux-like thinking and open source orchestration software. With open networking, we can follow this thinking by leveraging white box switching, having an operating system that is abstracted from the hardware, and having an interface that takes us to the open source technology or traditional layer 2, layer 3. Okay, so we have this rack of servers now. All the servers are custom made, and we are ready to offer a variety of services over the internet that deliver computer functions through our infrastructures. In order to achieve that, we will definitely need to connect these infrastructures to the internet through some ISP. Due to the fact that our business depends highly on the internet connectivity, we might consider to go for more than one ISP. For the sake of this argument, I'll assume that we have two ISPs, maybe one link via Verizon and the other one via PCCW Global. And of course we will use our white box switches, which we have loaded them with Stackflowos to give us layer 2, layer 3 functionality. So at the end of the day, we have something that looks like this, the big picture that is. At this stage, we are ready to accommodate our tenants who are actually coming from the internet to have access to our infrastructure resources. We will have to make sure that our network is properly segmented so that the traffic from tenant C doesn't end up to tenant B resources and vice versa. On the demo session, we will be busy doing the configuration of these white boxes. I need to stress this despite the fact that our tenants do share the same infrastructures. However, we must set them up in such a way that a tenant is going to have its own network stack, that's own routers, firewall rules, and network device. So at the end of the day, they are completely three separate networks, as you can see on the diagram. These are three completely separate networks which operate simultaneously on the same infrastructure to provide service back to the users. So now the user of these three networks are free to choose whatever IP address they want, whatever VLANs they want. At this stage, it should not be of any surprise to know that it's possible to provide IPsec security and a secure socket layer, that's SSL, VPN capabilities for site-to-site or user-to-site, secure communication taking place with the virtual layer. This enables organizations to connect their public cloud resources whenever from single or multiple provider. Let's prepare the system that we want to use for our lab environment by making sure we have VirtualBox and DNS3 installed on our system. Regardless of operating system you're using, these tools, they are free and they work cross-platform. I'll be in Ubuntu 14 as my OS operating system of choice because it's free and very flexible in every way you would think of. It will need to make a trip to the internet as well as to grab Stackflowos from cloudtest.blogspot.com. Alright, I will assume at this stage you are at cloudtest.blogspot.com, and once you're here you will need to go, probably the file is somewhere here. You will need to come down here and straight to SDN Start Kit. Okay, so you come down here to SDN Start Kit, and of course you will see this is it. So this is what's up. This is the file that this is the place where you'll need to go. So you can go ahead and click on this particular link here. Alright, so I will open this new tab, or otherwise it's also possible that you can also go here, okay, and open a new tab, and whatever suits you. So you can you will come down here, okay, and this will actually the Google Drive, this is awesome. So you will need to do it on Google Drive right here. So you click this particular link, it takes you here to the Google Drive, and then from here you can just download this particular file from here. And as it regards to the password and everything, all the details they are right here, and the password and username, they can always be changed. So you will need this particular file, and also you will need to get some the files from this site as well. You will need to come here and get the SDN Starter Kit. So you just go to Project SDN Starter Kit, and I feel maybe if you kind of let's go to the home page here first, because I feel like maybe this is not very clear. If you just keep on scrolling down like this, you know, and just keep scrolling down, and then eventually we will come to keep on scrolling. Okay, so you go to the old post. This is just another way you can get this particular file. I'm just trying to show you some alternatives here, and you keep on scrolling down. You see we have come to this place. It's just it just depends on how you want to do it, but it's the same information there. So you come to SDN Starter Kit, and then you do that. Let's, you know, what I haven't tried is let's try to, Google this stuff. Let's search, okay, let's try to Google this stuff and see what will okay, so you see right there you get the link, and you can also come here, so you can also Google this stuff and get it. So okay, you can try there. This is actually the link, so this should take you right there. If you click there, so this will take you, so you can Google this SDN Starter Kit Stackflowos, and then as you have seen there, it will take you there, and then I'm just trying to show you some alternatives here. Really, it shouldn't be a big problem, but the link that is guaranteed to work is actually this one from Google Drive, okay, which is this one that we've opened here. Once again, I'll go ahead and open a new tab. I'm just trying to show varieties, and then you get the file. Now, as regards to the SDN Starter Kit, here it is. So you will need to download this. So you will need to download this file. So you can download the VM right here. You see this download VM. Download this particular VM, and we are good to go. I mean, once you have this particular software with you, this one is very important. You need that, and you also need the stack of controllers. Here we have all the stack of controllers and all that. And then yeah, once we have them in place, and then we can proceed to have fun. Yeah, so why not? Please go ahead and download now, and then once you have it right there, you have got all the details once again here from this particular website. You have got your username, you have got the password, this everything there. You can change the username, you can change the password later, and we get it rolling. Alright, to proceed with the proceedings, so go ahead and locate where I have placed the overfile that I've downloaded from cloudtest.blogspot.com. I will import this particular overfile into the VirtualBox environment. I will change the name here to GW, that is a gateway of course. I will change the RAM to 512. I'll go ahead and enable the reinitialization of the MAC address for the network adapters and hit import. This is going to import this particular overfile onto the VirtualBox environment, and within a minute or two we should have a VM that is ready for us to use. And we do have a VM that is ready, so I'll go ahead and power up this particular VM. The VM is booting, and soon enough we should be prompted with the login screen. I'll go ahead and log in as user root. I will authenticate by supplying a password. If you press the up arrow key on your keyboard, you should see the command that was used to install various apps. I intentionally left the command on the history buffer so that you can see what and how the apps were installed for your own reference. Uname -a, this is going to go ahead and reveal the current kernel in operation. And if you want to take a look at what features and functionality this particular kernel has to offer, just take a look at the configuration file that was used to compile this particular kernel. I will exit out. It's always a good idea to go ahead and get the updates from the internet. So I'll go ahead and get the updates. This is going to take a minute or two, depends with the speed of your internet connection. And once the update has finished, it's always a good idea to take a look at the upgrades, if there should be any. And we see at this time of recording we do have several packages that needs to be upgraded. So I will go ahead and hit Y here for yes, and hit enter to accept the installation of the upgrade of these particular packages. Now here depends with the speed of the internet connection. Once again, it may take a minute or two, but for me, I will go ahead and put you on pause and come back once we have finished to install all the required upgrades. So I have successfully upgraded the packages. So what you should be aware that for now this particular system has no any security implementations in place that will actually stop you from installing various apps whenever you need. So to demonstrate this, I will go ahead and install DNS mask. This is just a light version of DHCP and DNS all in one. So I will go ahead and specify Y here and hit enter. This is gonna install the DNS mask app, and within a minute or two we should have it up and running. And indeed we do have it up and running. You can just ignore that particular error there. This is because the bind is also listening to that particular port 53, and we have not done any changes as far as the configuration is concerned with the DNS mask file, so that's fine there. What you need to do also is you might need to consider to change the time zone. So you can run this particular command to change the time zone. So for instance, I am currently in Africa, and Dar es Salaam to be specific. So I'll change to that, and I'll go ahead and power off, since we know everything works fine from here now. And what I will need to do at this stage is go ahead and clone this particular VM, and I will call it what about flow forwarding router. That's what's up. Also, I'll call this flow forwarding router. I'll enable this functionality here to initialize the MAC address for the network adapters. Hit next, and here I will default to the default. I won't do any changes here. I'll just say clone, and this is gonna clone this particular VM. So soon enough we should have another VM that is called FFR, being originated from GW. And Dido, we do have a VM. We have two VMs now, FFR being a product of GW. That's okay. So far so good. What I'll need to do now is go ahead and introduce you to GNS3. Now, if you don't know what GNS3 is, don't worry, because GNS3, the way that we're going to use here is just as our graphical terminal server. So I will start GNS3 here. And once I'm here, I will call this SDN. Call the project name SDN. I'll go ahead and say OK. You might be on a slight different version of DNS3, but that's okay. You should still be able to follow along. This is the current version that I'm running of DNS3. This is the version that I'm running on. You might be in a different version, but once again, you should be able to follow along. I will try to make things very clear so that you can still follow along within your environment, regardless of the version of DNS3 that you're running. So what we need to do at this stage is to get these particular two VMs onto the DNS3 so that we have a much more consecutive way of working. Alright, so what I'll do is go to edit and then go out to preferences, and then once I'm here, I will go down to the VirtualBox and go to the VirtualBox gates, and here, as we see now, if I go to the VM list and hit this arrow down key, I don't see any VM there, so I'll hit the refresh VM list, and then now once I go back there, and we see we have got our two VMs. Okay, so I'll go ahead and specify FFR, and then FFR, this is for flow forwarding router, and then I will enable the number of NIC, that is network adapters, to 24. This is just a standard switch. I will uncheck this option here because I want to be able to control all the 24 ports that are available with the network adapters. I don't need any assistance from the system, so go ahead and hit save, and now we see we have got the VM there, and the name is also revealed there. Alright, so I'll go ahead and import the second VM, which is GW, so I'll change the name here to GW. For the number of network adapters, this one I will change to 4, and hit here I will leave everything okay unchecked. So just go ahead and hit save, and now I have GW down there as well. So I'll go ahead and say apply and hit OK. Now once again, this depends with the version of GNS3 that we're running. It might be slightly different, but you'll still be able to get along. Alright, so I'll go here to browse for all devices, and then I will go down to the VirtualBox and drag this icon here onto the stage and let it go, and then we see this FFR. I'll say OK, and then I'll do the same thing again to get the GW in place. So now I have got my two VMs here in place. Let's see, this is very flexible. I can arrange them the way, whenever and how I want them. So I'll change the symbol here as well. Okay, I'll change the symbol to gateway and hit apply. Okay, you can change the name, you can do various stuff, but for us now, just go ahead and change the symbol, and this one will be a route to switch processor, and say apply and then hit OK. So far we are successful with lots of things that we have done, but there is one catch though to this. We need a way to administrate these boxes from outside. Okay, outside meaning from our LAN environment. Now to demonstrate that, I might need to bring a terminal session. Let me just start a terminal session here. Alright, if I do IPA, this will list all the network interfaces that are currently available on this particular box, the box that I'm using to record this in. Alright, so I have various interface, and you also see the status of this particular interface, including the IP address. But what we need to focus on is P3P1. This is the main interface, the main network adapter, which you can tell I'm running obvious on this particular system as well, which is actually bridge to bridge 0. So I want at least GW, this is the box right here, to sit on this particular network, 192.168.10 network, as for RFC 1918 address. Okay, so this is the network that we need to sit on. All right, so to do that, if I go to OVS VSCTL list port, I want to list the ports. I want to list the ports on bridge 0. So that's what I want to do. Now here, you see we have got P3P1. Okay, this is the main port that I was talking about earlier. It's right here. This is the port P3P1. This port has just been bridged to bridge 0. So the port that we need to connect our device is this one, P3P1. Once we connect to P3P1, hopefully we are going to end up sitting on this particular network, 192.168.10 network. Right? So to do that, I will remove this aside. I will need to get I'll come down here to browse for all devices again, and I need to get several tools, if you may. I'll get the cloud, and I'll get the Ethernet switch. This will assist us with that process. Okay, everything will be clear in a minute. So I will arrange them however I want to arrange them, so that I get a room here. So I'll bring this one down. Okay, now we have a space here, so I'll go ahead and hit configure on this particular cloud. I'll come down here to C1, and then right here I will press this down or OK. You see, we see all the list of the network adapters that was revealed earlier. This is the same list that you see here. It's this one here. So what I need to do is go to P3P1 and say add. This is going to add this particular interface down here, and I'll say apply and hit OK. Now we have that interface down there. So what we need to do is just connect this particular box of ours to that cloud, and boom, there we go. So here is the cable actually. This is the virtual cable that we can use to connect. This is similar to being on a physical, if it was a physical equipment, I mean you will need to do some physical wiring as well, so there's no big difference there. Now what we need to do, if I connect this, it actually doesn't like this, it's going to back at me. Okay? So I cannot do a direct, a one-to-one connection there, but what we need to do rather is connect this particular interface, okay, onto this switch here. Now I can connect to any port, but for simplicity I'll just go with port 1. And now this particular box GW, I'll go ahead and connect it to port 2. Okay, the port here really doesn't matter, but that's okay, I'll go with port 2. Now what we have done is we should have a connection back to the main one environment. So to test that, okay, let's just go ahead and boot up this particular VM. Okay, while that is happening behind the scene, I can also go ahead and connect this one to it. This is ETH0. I'm connecting to ETH1 here, but we'll come to this end a bit later on. I just did some basic connection there. As you can see here, I have FFR on ETH0 going to ETH1 on this gateway, and we have ETH1 on this side on the gateway going to the switch on port 2, and switch port 1 is connected to the main interface, okay, onto the cloud there. This is how the setup is. So let me go ahead and locate my my GW box here. So I need to log on to this particular box now. So I will go ahead and specify user root and the password again. Alright, so now we are inside this particular box here, and what I need to do is actually change this host name, because the host name now is a bit different. So now do etc hosts. Alright, I will change the name here to GW. GNS3 is so flexible. We have this very good graphic interface there. Okay, so I've changed the name to GW on the host, but now for the system wide I need to do it on a host name here. This is host name. I will change this to GW. Alright, and there we go. So we have changed the host name, and I need also to do some changes on the interface. etc network interface. I need to specify the address here. I don't want DHCP. I want to have a static address, and the address that I want is 192.168.10.210. How about that? And net mask of 255.255.255. This was /24. Okay, and 192.168.10.255. I'll specify gateway as well, 192.168.10. This one is 252. Okay. While I'm here, I can also go ahead and bring up the other interface, ETH1. So I will comment this one. Okay, I'll put some comment here. I will say this goes to LAN. No, actually not LAN. 1. Let's try 1 FFR, and I will change the comment here as well. This comment I can change it to cloud. Let's say cloud or internet. Internet cloud, maybe like that. Okay, anything that makes sense for us. Now here, out to ETH1, I'm just bringing up where make sure ETH1 comes up whenever the system boots, and then I'm specifying here the interface ETH1. This is IP version 4, and it's a static. Okay, and address, the address that we want. Address, it should be 172.16.0.1, and a net mask of 255.255. This is /30 255.252. Okay, and broadcast. The broadcast here should be 172.16.0.1. 0.3. Alright, so here this is what we've done so far. We have two interfaces. The first interface, Internet Cloud, this is the one that connects us to the Internet Cloud over there. And the second interface, of course, is this interface down here, alright, which is actual this one here. So it's going to 1FFR. Cool. Control O to save, Control X to exit out, and at this stage I'll go ahead and reboot. The reason why I'm rebooting is actually so that even the name will change, because we have done changes on the name, but you can see the name still represented the old name that was there by default. So soon enough, when the system comes up, hopefully we will have our changes in place. This is gonna take a minute or two. Alright, so we see the system is up now. I'll go ahead and log in. You can see the name has changed there, so I'll log in. I will authenticate, specify password that authenticate. If we do ifconfig, now we should see all the interfaces. They are up there. We actually see one interface, so if I do ETH0, we should see ETH0 also up there. At this stage we can try to ping. Let's just try to ping the gateway. We'll ping the gateway, which we specify to be 10.252. Oh, okay. I think no, the problem is on my end. That gateway is not running. So let me ping something else that is reachable. Okay, so alright, I specified the gateway, but the gateway is not running, so I need to fix that issue there quickly. That is a problem within my network environment. Actually, it's not a really big problem, it's just I forgot to turn on the gateway. Alright, so the gateway is coming, but everything is fine really here. Everything should be okay. You should be able to communicate with your network. So what I'll go ahead, while the gateway is booting, I will from this particular from this particular box now, I will not be able to ping that IP address, because I have got some firewalls and stuff like that that will deny me to do that. And I can actually show you. This has nothing to do with that particular gateway, but I am sitting on a different gateway. Let's just start doing this. If I can reveal that to you, this is the gateway that I am actually working on. Alright, this is my gateway, and if I do IP root list here, I'll see we have the gateway of 252. So these devices, they're sitting on two different gateways, and they have some firewalls issues here. So what I need to do is SSH to a box that I know has got no restrictions. So this will be 10.1, that is 10.1, this particular box. So from this particular box, I should be able to ping 192. I want to ping 192.168.10.210. That was alright. So I am able to reach there, which means I should be able to SSH. I should be able to SSH to accept these keys. I will specify password. Alright, now I am in on this particular box from remote actual, and if we do a route -n, you see we were sitting on a different gateways. So did I show you the default gateway on no, I didn't show you. If I exit out, I can just show you. If I exit out and run IP, you see, you can tell this is the gateway that we are sitting on the same gateway. So this is 252 and this one is 1052 as well. So that's what's up. So I'll go ahead and go back to this particular box. Everything works fine as far as the connection is concerned, and now the gateway is actually up. So now I should be able to ping 192.168.10.252. That was the address that I wasn't able to ping earlier, right somewhere above there. Yeah, there you can see I couldn't ping that IP address from here. So now if we ping that IP address, everything should be fine. Okay, it was just not turned on. Alright, now we have successfully configured this particular interface. This will be our main interface taking us to the internet, and now we need to configure this particular host. So if we do IP this will reveal we have got two interfaces, ETH0, which is currently up with that IP address there, and ETH1, which is currently up with this IP address here. So we need to configure this guy, this box here, with this particular IP address. So this box here should be configured accordingly. So I'll go ahead and power up. I will log in here. I'll specify password. Now once I'm here, I will just go ahead and change the name. So this, we want it to be flow forwarding router. So this is flow forwarding router. Flow forwarding router. We'll change for the system wide. That is flow forwarding router. Flow forwarding router. And I will save this file. I will go ahead now and reboot this system. Actually, I'll boot for the effect to take place. Alright, the system is up now. I'll go ahead and log in as user root. I will specify password here to authenticate. Now here I will use OVS actual. So OVS VSCTL. This is Open Virtual Switch Control command to add a bridge. So we are adding a bridge. This I'll call it bridge 0 for simplicity, but the name can be anything. And what I want to do now is add a port onto this particular bridge. So I'm attaching a port on bridge 0, and that port is ETH0, which I'm attaching to bridge 0. Alright, and yeah, that's about it. So to make sure if the port is up, I will use Open Virtual Switch Off Control to show me the status of bridge 0, the one that we've just created, and we see we have got two ports. Okay, ETH0 connect. This is a physical port ETH0 connected to port 1 on the virtual switch, and bridge 0, which is actually currently down, it's connected to the Open Virtual Switch port local. Okay, but I will go ahead and bring up that particular port which says is down, bridge 0, by specifying an IP address to that one. So that IP address will be 172.16.0.2 with a net mask of 255.255.255.252. This is /30. Okay, so by doing that, now we should see the port is up. Okay, and if we do we can do ifconfig, why not, if we run fconfig on bridge 0, we should see we have got an IP address there, and we can of course go ahead and add let's add default gateway to 172.16.0.1, which at this stage it's just a default gateway. It won't do much. We cannot go to the internet because we need to masquerade and all that, but that's coming up next. So far so good. Can we ping this IP address? We haven't tested that. Let's just try to ping the gateway and see if we can reach it. Yes, we can. So that means from, if I bring my terminals, okay, so that means from here we should be able to SSH to 172.16.0.2. okay, we accept this, and soon enough we should be prompted with to authenticate. Okay, I will go ahead and specify password there, and now we are in. Now once we are in here on this particular box, I will so now we are in. If we do route -n, we have got a default gate of that. I will exit out of here. Now what we need to do from this particular box is test IP reachability. So if I ping, I'll ping anything from outside, let's say 30, that works. I will ping, let's do internet 4.2.2.2. This is a freely Google maintained their DNS server, which we can reach it. That means we can reach the internet. If I dig Yahoo, for instance, .com, can we resolve? Yes, we can resolve, because we actually have a DNS running within our environment. So that's what's up. If you don't have a DNS running within your environment, then you can take a look at, you can replace this file in etc resolve.conf within your environment and change that to 4.2.2.2. Use this freely available DNS from Google, and then hopefully you should have internet working in case everything is set up properly within your environment. Okay, but if I SSH to this particular box, just try to verify here, we will see from this particular box, if I ping 192.168.10.252 for instance, this doesn't work, and a ping of 4.2.2 will not work as well, and a ping of what about a ping of 210? This works. So I will exit back. I'll do ifconfig. Alright, so now what's happening is on FFR, this is the box down here, it's trying to go out with this particular IP address, okay? And it's actual, that IP address is denied access by the gateway, because on internet you cannot send private IP address, so we need to masquerade somehow to this IP address here, and then that IP address will be able to forward us outside, because currently as it stands, this host, when it wants to communicate to any host on the private cloud and also on the public cloud being the internet, it sends all the traffic with this particular IP address, okay? And then this particular IP address just get blocked because the system doesn't understand that, okay? So we need to masquerade to this particular IP address, and then we'll have a privilege to go to the rest of the cloud. If I sit here and ping 172.20.10.1, I believe, you see this one works, but this is another IP address on the cloud. But if we go back to this particular server and issue a ping of 172.20.10.1, you see it doesn't work. So back to the main concept where I said everything goes out with this particular address, but this particular address is being denied, so we need somehow to masquerade with this particular address, and then things should work. Otherwise we might need to create routes and all that, but I'm not going to do that. But otherwise I'll just go ahead and masquerade. Okay, now I will exit out of here. I will go ahead and introduce you to Showall. Showall is one of those great tools that we use to manage the IP tables and net filters, of course. So you can do it with IP tables, but again, for me, I will use Showall. So if I can just take you to a trip to Showall. I need to, so this is Showall. This is the official Showall website. As you can see, it has got a very good documentation, by the way, and you can download if you want to download the latest and greatest Showall from there. But here, this is the program that we're going to use. Okay, so I will go ahead and enable some basic configuration here. It has got an excellent document that you can always read from the internet. It's cool, but I'll just go with the very basic of it here. I will make sure Showall startup whenever it boots there. That's what I've done. And now I will need to create what we call zones. So I will have to define the zones. I will go to etc Showall and create a zones file. This file is going to define, I'm going to define some zones here. Okay, what I've done here is define these two zones. So I've defined the net being a presentation of internet, and just IPv4, because IPv4 address, you can use IPv6, but I'm saying for the internet we're using IPv4, and for the local zone I'll be using IPv4 as well. And of course I've also defined there the firewall. Okay, so I will save this particular file and exit out. The other file that we need is the interface now, because we have defined the zone. Now we need to define the interfaces as what zone sits on which interface, or which interface do we find what kind of zone, what type of zone. Alright, and by default here is the settings. So I'm saying from a network or internet zone, this is ETH0, and for the local zone it's ETH1. Okay, it might be different, it might be the same, but that's what's up. And now we need to define the policy. I will create some policy here. Now a bit of a warning, these policies that I've created here, these are just example policies. This is not something that you take into production, and even in the lab environment I wouldn't recommend this kind of settings at all for your policy, unless you know what you're doing, or maybe you are tweaking it around with the rules and all that. Yeah, maybe, I don't know, but well, for me it's okay. I will use this policy, man. But for you, just be careful as what you're doing there. Okay. And now for the most important part, I will do the masquerade. So the mask, this is where we change from one IP address to another. So I'll say the main interface is ETH0, and the IP interface ETH1 should change to ETH0, to the IP address of ETH0. That's what I'm doing there. Okay. So now we need to also take a look at this one file which is on the show config. This is show.conf file. This is where we enable forwarding. You just need to make sure IP forwarding is enabled right here. So we will have to turn on IP forwarding, of course. Okay, so we do that, and now we should be able to say show all check. Alright, so okay, we don't see any errors. That means we can attempt to start show all and hope for the best. So now we have enable and start show all. Show all is in operation. We can take a look at the status, and if you're stuck, you can also do help, and you see all the various commands that are available for you. Alright, so you should be able to get along. It's a very straightforward, actual. It's one of those straightforward tools as any other tools within the Unix environment. They're all user friendly and they're very cool to use, and they have very good documentations. So now I will go back to this particular box and in, and right now from here let's start with local cloud. There were some IP addresses that we could not reach previously, like this one, 10.13. Now we can reach that one. That means our 252, our firewall is working fine. We can reach that one. Let's this is just a local cloud that I'm trying first. 172. That was 20.10.1. Let's try that one. Yeah, we can reach that one. Let's try Google DNS, and yeah, we can do that. Let's try to dig yahoo.com, and voila, this guy is returning. So everything works fine, and the reason why, if we take a look at the etc resolve.conf again, you see we have a DNS here. So within your environment, just in case you are having trouble with the internet connection, make sure the DNS is properly set up, okay? But otherwise we have sorted that challenge of internet connectivity and all that. So now we have more interesting stuff to come. What we need to do now is go ahead and bring in 4 hosts. So I will use the same overfile that we have used to bring these other 2 VMs here. I will go ahead and use that overfile to bring 4 hosts down here. Now in your case it might be different. I mean, maybe you don't want to do that, and then you can use, maybe you have some Cisco images, you can go ahead and do that, or maybe you can use VPCs and all that. But for me, I wanted this lab to be really of OpenFlow, Stackflowos. So everything here is going to be involved with Stackflowos, as you can see, from the gateway up to the client side. So I will use the same overfile, okay, to bring in at least 4 devices down here. I will connect them, and then we will proceed. So I will put you on pause while I am processing those 4 devices, and once I've got them, all of them, onto the VirtualBox environment, onto the DNS3 environment, and then we'll go ahead and proceed. If you have any problems of doing that, you can just rewind this particular video and watch how we have brought this particular gateway onto the DNS3. The same applies to this particular FFR onto DNS3. Alright, so far what I have is something that looks like this. So I hope in your environment you have something that looks like this. These are the VMs that I went ahead and brought into the DNS3 environment. So I have got 4 VMs, and I went ahead and specified this particular IP address or networking on these particular VMs. So they're all sitting on 10.1.1 network. This one being .2.1 and this one being .2, and so forth and so forth. And we have a default gateway of 252. Even though this side I have not yet, I haven't done any kind of configuration. I've only configured the clients with IP address, but this side is not yet done. So I have actual connect this interface. The way I've connected this device is I have connected ETH1 on FFR, that is flow forwarding router, onto the first VM, VM01, and ETH2 on FFR side is actually connected to VM0. They all have one interface, these VMs down here, which represent somehow, it could be anything, it could be a PC, it could be a server, or anything really. Okay, so we have got this flat network here of this range. Alright, so now I will go ahead and boot up this particular VM so that we can zoom in further. In fact, I'll go ahead and boot up all of them. Alright, so let's check the status of this VM. We'll start with the, okay, the first VM is actually up, so I'll go ahead and log into this particular VM. I will specify password here to authenticate. Now once I'm here, I will do ifconfig, and we see we have got one interface, or you can say two interfaces, the other one being a loopback, and ETH0 is our main interface, which is with that particular IP address. Let's try to ping that IP address, that is 10.1.1.1, okay, and sure indeed the interface is up, everything's fine. Let's try to ping the 2, for instance. This one fails, and let's try to ping the 3. Yeah, this one fails. Okay, so let's go ahead and log in to the second VM. Alright, I'll log in as user root. Once again, I will authenticate by specifying a password here, and I'll go ahead and issue an ifconfig on this particular interface VM. So we see it has got a IP address of 10.1.1.2. I will go ahead and do some basic ping test. So I'll send some echo request to the same interface. Okay, pinging the interface itself. I will try to ping .1, doesn't work, and I'll try to ping .3, doesn't work. Now this takes us back to how we have configured this particular switch router. We are using obvious. Alright, so now what we need to do is actually define that particular switch. We have to create a switch for things to work smoothly. I will go ahead and demonstrate this. So I need to SSH to 172.16.0.2, that is, and I will specify a password here. And if I do obvious vctl show, this will show that we have this is the database ID, and this is the switch that we have so far. We only have one switch, which is actually attached to ETH0. So port ETH0 has been bridged to this particular switch, which is bridge 0. If we do an obvious of control show bridge 0, this will reveal the same information, but maybe a little bit more detailed, because now we see we have got a port of ETH0 which is actually configured, so it means the administrative status is up, and also the state there we see it's the state is up, which means the interface is actually functioning. Okay, and this is the physical interface being attached or mapped to the first port on the virtual switch side of things, and bridge 0 being mapped to the local interface on the open virtual switch side of things. And this what we also see here is obvious obvious off control command actually reveals that it also runs flows of open of version 1.0, and that's the default flows that we have out of the box when you create the switch the way we did with obvious command, actually obvious vctl add bridge. This time around we'll go ahead and create bridge 1, for instance, just to show what happens behind the scenes. So we create bridge 1. Okay, so now we should have, if we do obvious vctl show, this will reveal we have got 2 bridge now, aka 2 switches, one being bridge 1, which currently it has got only one port, which should be bridge 1. Let's just go ahead and zoom in, obvious off control, so we'll check the flow control, then we say show, this is going to be bridge 1. Alright, so this actually reveals that so far we have got only one port, which is actually bridge 1, and that one is split to the local port, and currently it says the configuration, it is not being configured, is down, and also the status is down. That means it's down. Okay, alright, so and the version again out of the box is version 1.0. alright, that's basically it. But now creating this particular bridge doesn't bring up the interface. I mean, this interface now we need to actually not only bring up but also add the interface on the Open Virtual Switch side of things. So Open Switch should be mapped with those interface. If I do an if config, we'll see on the current level right now we only have ETH0, this particular interface. Alright, so now that we have created bridge 1, we also need to attach interface onto that particular bridge for things to happen. So I'll go ahead and do that. So I'll use obvious vs virtual switch control add, and this time I'll say port. I will specify port bridge 1. So what I'm saying here is on switch 1, on bridge 1, add this particular port, which is ETH1. Alright, and this is actually for the first VM that is connected there, VM01. This particular VM down here, it can be revealed from, if I do this, should be revealed that we have ETH1 on FFR going to ETH0. So here we have at ETH1. Okay. All right. Let's just go ahead and proceed with the proceedings. Okay. Now that we have add that particular port. Now, and by now you should be aware that IP, as many other things in life, is two-way communication stream. That means even though we have added this particular port onto this particular bridge, we need to actually do the same thing for the other port as well. So in order for things to happen, so I will add ETH2 for instance, and now if we do obvious VSCTL, if I do off control, let's look at the flow, and this time we take a look on bridge 1. Alright, not really okay. So here what we see is the status. Now we actually looking at the status of this particular port here, which is this particular switch. We are looking at the status of this particular switch at the moment. So what we are seeing here is the interfaces that are down, ETH1 and ETH2, the interface that we have just added a while ago. And the reason why the configuration, the state is down is if you do ifconfig, you will notice that we still have only one particular interface here, interface ETH0 and interface bridge 0. Now I will go ahead and bring this particular interface to up. So I will use ifconfig. This time around I'll use ifconfig. Then I'll specify an interface here, ETH1, that is. I'll say 0.0. So they'll specify all 0 there and say up. Okay, and this now should bring the interface to up. Now we see we have got ETH1 interface up. And now if we run the previous command and take a look at the status of this particular switch, we see ETH1 now the port is actually up. If I go ahead and bring up this particular interface, now the way I'll bring up this particular interface, for now I will use again the same command. So I'll say this one is 10.1.1.252, and I'll specify net mask of 255.255.255.0 because this again was /24. Now if I run this particular command, we see the interface now is not complaining being down. And if we do let's do ifconfig here and check out the status, now we see we have got ETH1, ETH0, bridge 1 notice there, and bridge 0. They are all up. Now I should be able, if we take a look at obvious, let's take a look at this particular switch and see what we know. Okay, so if port 1 claims to be up and local port claims to be up, I should have IP reachability between these two interfaces. So this interface should be able to ping that particular interface. Let's try to ping from here. We are pinging 10.1.1.1, right? And sure enough, this works. And we can go ahead and do the same thing. Let's go to that particular VM, which is this one. Now let's try to ping 252, and voila, it works. So now we are able to ping our gateway. So far so good. And previously, remember, we couldn't do that. Okay, so that means that our obvious switch is properly configured at this stage. And if you are wondering, if we do obvious, because this again, remember, it's the open flow switch, so if we do obvious of control and then we say dump flows grid 1, what we see here is a basic flow. If this particular bridge, if the new created bridge does not connect to the OpenFlow controller or system admin intervention being involved, what we'll end up seeing is something like this. So we have the lowest priority here of 0. So this means this is just a simple layer 2 switch which floats packet received from port to all other ports. Alright, and the action normal here, that means the packet actual, or the device it's able to process the packet subjected for layer 2, layer 3 processing. So these packets here, what it means is just these packets, they're ready for layer 2, layer 3 processing. That's the action of normal there. So that's what's up. And no wonder at this stage we are able to ping, and everything works within our LAN environment. And that's simply because of these default flows, which is the actual of version 1. Okay, so right now verify these settings. So I'll use obvious vctl add port bridge 1. Then the port that we want to add on to bridge 1 is ETH3 this time around. So now if we do ifconfig, we see we only have 2 ports that they are actual up, that is ETH0 and ETH1. Command obvious of control, I'll say mod port, and we want on grid 1, this is switch 1, and the port that we really want is ETH3, and I'll say ARP now if we do obvious VCTR of control show, we want to take a look at this particular switch, and we see this particular port is current up, but this particular port is down. And okay, so I can do the same command. Okay, so I'll do the same command to bring up the second interface, and now I should be able to ping 10.1.1. That was 2, and I should also be able to ping .3. Alright, now that we have verified everything works, let's see what happens if we delete the flows, for instance. So I'll use obvious of control. I'll say delete flows, and I want for this particular switch. Now if we dump the flows, so if I should dump here to take a look at the flows, we'll see we currently see the version. Okay, so we are still running on the version that is 1.0, and we don't see any flows as previously. So let's go ahead and test our ping reachability for that matter. So now we see we are not able to ping. Previously we were able to ping, things were working, but now because we don't have any flows, then this will not work. It will keep on failing. Now the way that we can quickly resolve this is go ahead and attach a controller and configure it the way we want to configure it, maybe as a layer 3 switch device or a layer 2 switch device, but have the functionality out to the controller, and then that will work. Or otherwise tweak this flow so that it will work on your favor. So let's go ahead and take a look at how we could bring this particular thing up to resolve this. In fact, what I will need to do is actually change this flow. This particular, I don't want to work on flow version 1.0. Let's go with at least 1.3. okay, that has got some interesting features as well, so let's do that. So I will use this particular command here to set this particular thing to the version 1.3. so let's go ahead and take a look at the flows. Now we see we cannot actually run this particular command because again this one we were able to run this particular command while we were running version 1.0, but since now we are running version 1.3, you can tell even the command actually fails. So to rectify this, what I will need to do is specify the following. So we'll come down here and specify the following command. And hit enter, and now we see that it's returning the version that we are running, and the hexadecimal there notice has changed from previously, and this one reflects actually the version of the OpenFlow that we are running. But this still does not actually have to do with anything with I mean the pflow. We still need to create the flows. This is just the version that we are running actually, but we still don't have the flows. Now let's see how we're gonna go about creating these flows. So I will just go ahead and zoom in to breed 1. Okay, let's take a look. Okay, you see I just went ahead and I'm trying to show you what will happen in case you don't actually specify the version number that is required, because from now onwards whatever you want to do you will need to specify the version that this system understands. So once you have the correct version, and then you can always run that particular command. So for instance, now everything works fine here. We see the following. So we see we have got ETH1 on this particular interface. So ETH1 goes to port 1, ETH2 goes to port 2, ETH3 goes to port 3, and breed 1 to local breed. So we have 4 ports. Okay, so let's start with the host, this particular guy here, VM01, which sits here, should be able to ping VM02 and should be able to ping the gateway. Let's just go ahead and tackle that kind of flows as how we would have done. So I'll go ahead and paste in the command, and then I will explain. Alright, now I have got this very straightforward command which I am actually running here. What I'm saying is I'm using OpenVTSwitch OpenFlow control command, and this is the version that I'm showing, 1.3, and I'm adding the flows of course onto bridge 1, aka switch 1, and I'm saying on port 1, whatever comes to port 1 I will output it to port 2, which again is ETH2, where we have this particular host here connected. Alright, and I'm also outputting to the local port, which again is this one, the bridge 1. Alright, so yeah, that's about it. I'll go ahead and hit enter. Now once again, as I always say, when it comes to the communication in IP and everything else in life, it's just a two-way communication stream. So what we need to do is essentially go ahead and tackle and do it in a reverse manner, because now if we go, I mean, we don't really need to go anywhere. We can just try to ping from this side. Let's try to ping 10.1.1.1, and we'll see, even though we have the flow, because once again, if we dump the flows, so if I dump the flows on this particular bridge, we'll see we have this particular flow, but this again is one-sided. So let's go ahead and tackle the other side of things. So now I will specify here port 2. Alright, I will specify port 2, but now this time I'll output the traffic on port 1 and local. Alright, so now at least from PC 1 and 2, okay, if I bring this one should be able to ping at least 2 at this stage. Yes, it's able to do that. The TCP three-way handshake is happening, which is cool. That's what we want. And now for the local, I will just change this port here. I will say this is local. Alright, so I'll change this to local, and this one obviously I'll leave it to 1, and this one I will change it to 2. Alright, and then I'll do that. Now here we should be able to ping 10.1.1, and voila, things are working. And now we can also ping 10.2. These are just very basic flows for real. So things are happening, and once again we can always go back and dump the flows and see this is exactly the commands that we have entered previously. This is a very simple and basic flows. So now what I will need to do actually is if I go back and delete the flows, for instance, if I go back and issue now if I go back and delete these flows, we will notice okay, we don't have any flows now. If I try to ping, my pings should not work. Alright, that's just about it as regards to the flow. We see now our OVS is capable of running the flows, and we've seen the flows in action. I will go ahead and reboot this particular system. So I'll wait for the system to come. Okay, the system should be up by now. Let me just go ahead and confirm if we can SSH to the box. Alright, let's see our SSH sessions, the actual failing, and if we try to ping 172.16.0.2, we see our pings also fail. So let's go ahead and examine what exactly went wrong after a reboot. Why is our system failing? I'll go ahead and log in as user root. I will authenticate, specify password there. If I do ifconfig, I see we only have ETH0 and loopback interface. Okay, so things have gone, something has happened, because this is not the previous view that we had. We had some bridge there. So let's just go ahead and take a look at all this vctl show. So I'll use this particular command. I see we still have bridge 1 in place, and we have those interfaces in that particular bridge. And I also see we have got bridge 0. Alright, so and the interface is there, but if I do ifconfig, once again I don't see the interface. So if I do obs vctl of control show, let's take a look at the status of bridge 0, for instance. We will see the port shows down. So the port is down and the link is down. That means it's not configured, and that's why if we do ifconfig, we see that particular interface is actually not there. So alright, what we need to do is bring up this particular interface. So I'll use ifconfig bridge 0. I'll say the IP address for this particular interface is 192.172.16.0.2 with a net mask of 255. This was /state, I believe, 255.255.252. Alright, now right there you can see that our pings are starting to work again. The default is obvious does not restore the IP address once the system reboots. That information is of the IP address is not kept into the obvious database. So we need a mechanism to, when the system reboots, to bring up this particular interface and take it down whenever the system actually goes down. So we need a mechanism of how we can control this current behavior. Now, one way we can do this is actually essentially go ahead and write some scripts. Okay, so if we write some scripts, and then that will happen. Or otherwise, it's just to go ahead and use Quagga, and then Quagga can take care of that. Now, Quagga is just made up of several daemons. So let me just go ahead and bring in the terminal, and right here, let's just go. Now we should be able to SSH. I will go ahead and specify a password here. Alright, so now I am in. Okay, what we need to do is configure Quagga. Okay, so let me just configure Quagga in such a way that Quagga takes care of the, if I do a nano etc Quagga diamonds. Now we should configure Quagga in such a way it takes care of the interfaces. Now Quagga is made up of several daemons, if you may. I will go ahead and enable the zebra. So I will enable the zebra. This is actually the kernel routing manager. So I'll go ahead and say yes. So I will enable the zebra, the kernel routing manager, in conjunction with bitwise sh. This is an integrated shell for the Quagga. So I have enabled that. That's all I need there. Okay. Okay. So now what I need to do is actually some few files here. So then what I really need to do now is just go ahead and copy these files here. So I'm copying the Zebra file. This is the kernel routing manager. Alright, and then I will also need to copy the V2IHS, so and get the following file. Now this is again, this is for the V2ISH integrated shell. Alright, so now I have those particular files in place. If I list the file in etc Kuaga, I should see we have them in place, the Zebra and the V2ISH and the Zebra, of course. So let's just work out some few permissions here. So I'll go ahead and change the ownership there. And I'll change the mode bit there. Alright, so I've changed the ownership and I've changed the bits there. So that's what's up. Alright, so now we need to work out the environment for this thing to work perfect. Okay, so what I've done so far is change the ownership of these files, okay, to this particular user, and change the bits also, okay, and the more bits there, and we also change enable the configure the environment so that everything can work fine as expected. Now if I go ahead, now at this stage I'll go ahead and restart. So if I issue an etc init hd and Kuaga, so restart. So if we restart here, okay, now this is restarted, and I will exit out, and then I will come back and specify password. Now if I do V2ISH, now we can log in without any problems. And then if I do show IP forward, okay, so we see this thing is not forwarding, but IP forwarding currently is turned off, but that's not a big concern so far. It's okay. We have done that. What we wanted to use for this Kuaga, the reason we've brought here the Kuaga in the first place, is we want to be able to manage the interface. Now if I do obvious vctl show, this reveals we have three interfaces. Actually, I will go ahead now and obvious vctl delete, and I'll delete this particular switch or the bridge 1, that is. So I'll delete bridge 1. Okay, so now we should see obvious vctl list show. This will show we only have one particular bridge, and if we do ifconfig, we see we have we have two interfaces that are bridge 0 and ETH0, which is actually linked to bridge 0. Alright, so now if we do nano etc network interface, alright, so we see this particular interface has been set to DHCP. Since we want to put it to premix mode, I'll go ahead and change this particular behavior. So I'll say manual, and then I will follow it up with pre-arp. Right, I'll say ifconfig, and then I'll specify the following variable. Alright, so I want to bring it up, okay, and when it goes down, so I'll say post down, and then I'll say ifconfig, then I'll include this particular variable again, then I'll say down. So I'll set this particular interface down when the system is going down. Alright, so once I'm here, and then I'll go ahead now and save this particular file and exit out. That is for ETH0. But now notice that the bridge will not come up yet. Now, in order to work on the bridge, that's when this coordinate will be very handy. So go ahead and say config terminal. Alright, this is similar to SDN if you have an experience with that. Interface, and interface that we want to specify here is bridge 0, and then I'll say description. Let's call this 1. Let's call this let's call 1 GW gateway. Okay, the name can be anything that makes sense to you, but that's what's up there. I mean, for the description there, right? So I'll specify the IP address, and here the IP address once again was 172.0.2/30. You can use a slash notation here, and I'll say link detect to make sure it comes up, and then I will exit out and exit out from here, and then I can save. Notice this is going straight there, and save this one to the to this particular file here, and that's simply because by default we have left service integrated VTYS config on, and that's why we are working on this particular. So this will be our main working file. If you want to change the settings so that you can work on the individual files that we have brought up, we have copied and pasted on respective locations, and then you can just go ahead and disable this particular functionality, and then it should be writing to the different files. But for us now, we really want it to be on the same files. Okay, so that's what's up. So now I will just exit out, and if I reboot, you can go ahead and reboot just to justify this stuff works. Okay, we'll go ahead and reboot, and I hope when it comes back we should be able to log in. So I will do some continuous pin here. So do 17.16.0.2. Alright, so let's see if it's up or not, and let's check FFR. It's still coming up. Alright, now yeah, we see as soon as it came up, and then everything was back to normal. So now we don't have that particular problem, so we can SSH and specify password there, and boom, we are in. And now if we do ifconfig, for instance, okay, now we see the interface is there, and IPA should reveal the same information, but this time around with too many interface. Okay, alright, but that's what's up. So we see this particular interface of ours here, it's up. Okay, alright, so that's it. So far we have accomplished that, and we can create another bridge if we want. So obvious VSCTL, I'll say add, let's say this is a bridge, I'll call this bridge 1. Alright, and I can go to VTYSH and configure this particular bridge with an IP address. So I'll say configure terminal here, okay, and then I'll do interface. I'll say bridge 1, I'll say IP address, okay. This one I will specify 148.135.102. Let's do let's do 1. Alright, so .1, and then I will also specify a mask key. Now for the mask here, I want this to be /26. Alright, and then I'll say link detect, and then description, I will say for the description I will say let's call it net 0 is net 1. Okay, and then I will exit and exit out, and then save, and then exit. And if I do ifconfig, we see, what do we see? We see that particular bridge is instantly up. It's right there. Okay, so we have no issues there. And this time around, if I do IP route list, for instance, yeah, we should see this particular network. We have two networks now, this one being on this particular network, and we have another network. So we have two networks at this stage. Everything works fine here. We can essentially go ahead and obvious VCTL and add another add bridge. So I'll call this one bridge 2. Okay, and call this one bridge 2. And okay, so I've created this particular bridge. Now go back to V2SH and config. Alright, I'll configure the terminal. So I'll specify the interface. This is actual bridge 2. Description. Description for this one, I'll say net 2. Alright, and then IP address, I will say 148.102.65. Let's specify that with this particular subnet. So I am just subnetting this IP address, if you've noticed. And then I will say link detect. Alright, and then I can exit out and exit from here. I'll go ahead and save. Alright, so if I do show interface description, we should see we have these three interfaces all up, net 1 and 2, net 2, net 1, and that particular interface there. Okay, so that's what's up. I will exit out and do ifconfig. This will reveal the same thing. Okay, and if I do IP if I run IP route list, we should see now we have three networks within our environment. Alright, it's not a surprise by now to know that this cannot support virtual networks, aka IP namespace. If you have a background in Juniper or Cisco, this can be compared to VRF. Logical is just another copy of the network stack with its own router, firewall, rules, and network device. Let's take a look at a configuration file that we use to compile this scanner and zoom in IP namespace. And sure, we see like IP namespace module has been enabled. This means if we run IP net names help, we should see all the commands that are associated with network namespaces. They are so awesome in multi-tenant environment where you have overlapping IP addresses, and somehow these IP addresses or clients need to be treated somehow differently. So let's go ahead and zoom in on this particular topology. Suppose we have this kind of setup. This is actually what we have here. I have just gone ahead and zoom on this particular namespace. So that particular tenant. So that particular tenant is this one, net 1 here. Down here you can see net 1. This what justifies is we have got two particular networks, and there is a router here, and this particular IP address here, 148.135 network, this particular network here is the one that is taking these guys onto the internet and the rest of the clouds. So that's what is being revealed if we go back here. So we will have earlier I provision bridge 1. If I can bring the cloud here and take a look. I have config, so this will show. Alright, we do have bridge 1 here. Okay, so bridge 1 and bridge 2. So for the, if I can bring that diagram here, for the second namespace, which is this one here, you can assume that is going to be bridge 2. So that this will be bridge 2. So now the focus is actual on this particular namespace here. So that's why you are seeing this one. We have bridge 1 there. So once again, on bridge 1, the IP address will be, let's go to bridge 1. That particular IP address will be this one. So this is the IP address that will take this particular traffic to the rest of the cloud as from this diagram here, as from this diagram. So this network, all of this network, they will come to this particular router here, firewalls somehow, and masquerade to that particular IP address that we've seen there on the bridge 1 interface and go out. And the same applies to the coming traffic. Somehow they will need to masquerade to this particular IP address and then get access to this 10 network. This is what we need now to go ahead and implement for our tenants. Our tenants needs to have access to the outside world for incoming and outgoing traffic. Alright, so let's work it. Alright, okay, I'll go ahead and start by adding our first namespace. Okay, then I will go ahead and define the second namespace, and now we should have two namespaces, and that of course can be justified by running this particular command. So if we list, we see we have got two namespaces in place. On bridge 1, I will go ahead and create an internal OVS port. I'll go ahead and do the same thing for the second bridge or the second switch, but I will just go ahead and change the name here. I'll change these names here. Okay. This will be obvious in a minute is what we are doing, to be very clear. Okay, so now I have two internal OVS ports. Alright, and if we do OVS VCTL show, we should see we have tab 1, and we also have tab 2 on this particular bridge or switch. Okay, so that's cool. Alright, what I'll need to do now is attach this particular interface to the namespace. Okay, so I'll do that, and for the second interface to the second namespace, so this second interface is this one. Change the name that tab 2 to reflect what we have there, and this is our second namespace. Okay, so press enter. Now we have successful done that. What essential needs to do as well is actual set the device to ARP now. Alright, so I will bring up the loopback, and I also need to bring up the tap interface. So let's set the dev tap. Okay, so let's bring up the tap interface, tap 1 to ARP. Now if we just essential by doing that, if we take a look at ifconfig on this particular namespace, we should see we have our loopback interface ARP, and we also have our tap interface ARP. This is awesome. But if we go ahead and take a look at the second namespace, since we have not done these changes, we see there is nothing there. So let's go ahead and do the same thing for the second namespace. So I will do the same thing for the second namespace here. I will just bring up the loopback interface, and then I'll go ahead and bring the device. This is actual tab 2, and the namespace that we want is 2, right? So I'll go ahead and do that. And now if we do ifconfig, we should see we have tab 2 ARP. Okay, so we see this is what we have there. All the interfaces are ARP compared to this one on the first namespace 1. It's also ARP. So right now we can go ahead and configure some IP address on those interfaces. So I will go ahead and configure the IP address on this particular interface, and in fact here I will use 10. So I will use this particular IP address here, and yeah, just for no good reason really. You can use anything that you want within that network range. So I decided to go with 10, and that's what I'll do right here. And of course, if you specify a device that is not present, the system is gonna back at you. That's what I wanted to show you there. So you can do that, and then proceed with the other hang on, before going to the second interface, I need to specify a default route, which I will do it right here. So I'm specifying a default route there, and now we can move on to the second interface. Or before we do that, let's just go ahead and do ifconfig. Alright, we see now we have got an IP address, and we can also run a route -n. Yeah, we also see we have got a default gate of that one. Can we ping that IP address? Can we ping our default gateway? Let's see if we can ping 148.135.102.1, right? So yeah, we can reach that IP address. So this guy, namespace 1, is able to reach its default gateway. That's awesome. Okay. Alright, for the second namespace, I'm specifying the following IP address, and again, as you can see, I'm just throwing the IP address randomly. You might have a good design within your network maybe, and then just follow your guides there as regards to IP address. But for me, on this particular lab, I'm really throwing things around however I want it. Okay, and I'm also specifying a gateway right there. So that's what's up. And now if we go back and take a look at this one, we'll see it reveals that it has got that particular IP address, and we can do IP route list. Then we see it has got that particular default gateway. That's the default gateway. Let's try to ping that default gateway, which ping 148.135.102.65, that is, and sure enough we can ping that particular gateway. So far so good, but that is as far as the traffic is concerned going northbound. So that's what's up from northbound point of view, if you may. Then the traffic works. So from we have not confirmed yet for the tenants, because we need to add some more interface here so that we can accommodate these 10 network and the 20 network. So that's what we need to do. So far we have actual configured the access towards outside and somehow inside, if you may, but we are yet to go ahead and tweak it further. So let's proceed with adding this the interface here. So for that I will do the following. I will go ahead. I will actually go ahead and add bridge. This bridge I'll call it S0 for switch 0. So this is what I'm doing. So I'm just creating this new bridge, aka new switch. Alright, and then once I have created this switch, I can now go ahead and specify which ports I want them to belong to that particular switch. Alright, so let's do the following. I am going to go ahead and create an internal obvious port, just as what we did previous. Okay, so I have created this particular internal obvious port. What I will need to do is create actual I'll create many of these for VLAN 20 as well. So create for VLAN 20. It will be obvious as soon as we get to finish this stuff here. So I will do this. Okay, so I'll create this particular internal port, and right here I'll do the same thing. So I have VLANs. I'm putting this stuff, everything now to the VLANs. That's how I want to do it. And these are going to be my VLAN interfaces. So I need to do for 40 as well. Okay, so let's do that. Alright, so now I have got this particular bridge, and on this bridge I have got 4 VLANs. Okay, so I have got 4 VLANs on this particular bridge, and these are actually interface VLANs, aka the internal obvious ports. So what I really want to do is link these internal obvious ports to the namespace. In that case, we can now easily use the namespace and hope that it's communicating quite well with the obvious side of things. So the obvious needs to communicate to the namespace. Let's make it happen. Alright, so now I will set the namespace interface VLAN 10 to namespace 1. Alright, that's what I'm doing there. And then obviously I need to bring this particular interface, and there we go. I just brought this particular interface up. So the commands, they're just as previously what we've done really. So this is something that you can actually go ahead and proceed doing, but let's just confirm if there was some effect within our side here. So do I have config, and voila, this time around we see we have that interface there with that particular IP address. We also see we have got a broadcast and the mask there. Alright, so if we do route -n, we should see now we have got this particular network, okay, and which is actually on VLAN 10. Alright, and this particular network, and that's the default gateway there, and this is the other network that we have on VLAN 10. The other one is sitting on this particular interface here. So everything here looks to be quite interesting so far. What I will add you do now is go ahead and add the other interface, because you have already seen me doing that. I will put you on pause. I will go ahead and add all the necessary interfaces, and then once I come back, we'll just go ahead and do some basic verification, and then proceed. If we pay close attention to bridge S0, aka switch S0, we see now we are segmenting our network using VLANs, and we have actually used the internal ports to actually connect us to connect between Open Virtual Switch and the namespace. The namespace that currently running actual at if we list actual the current running namespace, they run under var run net names. We see we have got two namespaces that they're currently running, and if we do OVS VCTL list ports, let's do it on S0, the bridge S0. Alright, we see we have got VLAN 10, 20 up to 40. These, they are all internal connectors which we have used to connect between the namespace and between these two namespaces here and the Open Virtual Switch. In fact, what we have really accomplished is this so far. So if you take at this particular diagram, it should be very clear is what we have really done here. So we have our Open Virtual Switch there using this particular internal OVS port, of course, to connect between Open Virtual Switch and the namespace there. So that we have done it on all the current switch now, from bridge 1, bridge 0, and of course bridge 2. Actually bridge 0 we have not done that, so it's bridge 2. Concentrate here. Bridge 2, we have this internal OVS port which is actually connected to this particular namespace. This links us to that particular namespace, and we have bridge 1, we have that particular port there which is actually connecting us to that particular namespace there, and this tab here is connecting there to that particular namespace, and of course these various internal OVS ports here that we have used to connect to this namespace. So there is a connection between the Open Virtual Switch and the namespace as we speak. No wonder if we try to ping from here, let's do ping 148.135.102.10, this should work, and also a ping of 76, this should also work. What we really need to do at this stage actually is we need to do the following. We need to add these particular hosts on our tenant side to their respective VLANs, because now we see down here we've got a host which needs on this particular tenant net 1 which needs to be connected to VLAN 10, and a host again on tenant 1 which needs to be connected to VLAN 20 with the IP address down here respectively. I mean the network that they are supposed to sit on respectively. The same applies to net 2. So let's go ahead and work out that at this stage. So I'll clear the screen here, and now I just need to add this interface into their respective VLANs. So the interface that we are adding at this interface down here, as you can see, I'm starting to add the first interface, which is actual from FFR flow forwarding router. It's ETH1, which is actually connecting us to ETH0 on this particular host down here. So I will go ahead and add that one to VLAN 10, that particular interface to VLAN 10. The second interface is of course ETH2. This one needs to be on VLAN 20, so I will just do that. And the third one, the third interface, of course this one goes to VLAN 30. Alright, and the fourth interface, this goes to VLAN 40, and here it is. So far we have this kind of setup. So if you do obvious VCPL list ports on S0, now we should see we have got the internal obvious ports which we have used to connect between the Open Virtual Switch and the namespace, and we have this interface which we'll use to connect our hosts. And if we do OVS of control and show the status of switch 0, we currently see ETH4 being down, ETH3, ETH2, ETH1, they're all down. So let's take a look. The focus is actually on this particular interface now. The focus is currently on this particular interface right now. So we see all of them, they are actually down. I have shown you how to bring this interface manual using the obvious of control mode port command, and I've also shown you how to do the same thing using the ifconfig command. But this time around, let's make it permanent. We'll go ahead and tweak a bit the configuration, the network interface file interfaces. So I will make sure this all interface they come up. So I will set all these interfaces to premix mode as this one, and boom, through the power of video I have already done that. So you can see we have all this interface now that's sitting on a premix mode. Okay, and so far we should be good. So I'll go ahead and do Control O and Control X. If I do IP route list, so far we see, okay, we don't have a default route at this stage. Okay, so let's go ahead and use Quagga to set this one up. We'll go to config terminal and actual do show run config. This is the same as some of these commercial routers that are available there. You can just do the same command there, okay, including Cisco, by the way. So now I will say IP route. We want to route anything, should be sent to 172.16.0.1. okay, I will exit out, and then I will save this configuration, and then I will exit. Now if we run the same command again, we should see now we do have a default route, which is actually used Zebra for this one, but it's fine. Alright, so things are working, and the same information can actually be retrieved by running this particular command. It's just a different way of looking at this. Anyway, the same information is being retrieved from up there and here. It's the same thing. Okay, so I will go ahead at this stage and issue a reboot to the system so that the port comes up automatically without being involved. Okay, so we wait for the system to come back. Alright, let's see if the system is up now. We try to SSH. Yes, the system is currently up. I'll log in. Okay, now we are in. I will if we run ifconfig, we see we have all the interface up. Okay, and if I do obvious of control show S0, we see the link is down on this one. Okay, so that means this particular the link is down on port 4, right? Okay, we see the link is down here, but the rest they are up. Okay, from ETH1. Probably I will say this one is actually, let's go and observe. I think this is, we are on wrong port here. Yes, as we can see here, we are actually sitting on ETH6 and not ETH4. Okay, so I'll go ahead and rectify this. I'll delete this particular cable, and now if we go ahead and connect this cable to ETH4 and ETH0 down there, now I come back here and run the same command again. Now, okay, we see the port is still down. Give it a minute or two. Let's try. Okay, now the port is actually up. Right, so we were just too quick for that. But now the port is up. So we have all these ports, ETH1, 3 up to ETH1, 2, 3, and 4. They are all up. So that's what's up. Now we should be able to take a look at let's go ahead and take a look at the IP namespace. So now I'll go ahead and take a look at the namespace. Now we see cannot open a network namespace, no such file or directory. So we're getting some errors here. It seems like we cannot get the namespace. Okay, let's see what's happening. So netns, let's do list, and the list doesn't return anything. Okay, and if we do ls -r to list on var run net and it's not even there. So if we run this, okay, we see named, mounted. Okay, it's not even there, so that's cool. What has happened here is we need to script this. By default namespace, when you reboot, they're temporary. Namespace, they're temporary. So when you reboot the system, if you have not scripted them somehow to make them permanent, they will just disappear. So you need a mechanism to somehow make sure, like whenever you boot your system, and then the namespace, they're always there. They don't get disappeared, just as what has happened to us. When you come to obvious, let's do obvious VCTL show, we'll see nothing has changed as far as obvious is concerned, because it's preserving all these particular data on the database, on obvious database. So this is fine. We have all the information there in relation to our obvious ports that has been linked to these various namespace, but then the namespace, they're gone. So we need a mechanism to do that. So what we need to do is create a file here. I'll call this one vnet.sh. So this is going to be my script, and I will set this set x here actual. If you leave it out, okay, if you leave it out, this will not it will background the information once you run this particular file. But if you leave it like this, and then you have to see what's going on the screen, everything will be thrown on the screen. So basically what I'm doing here is I'm really defining my namespace here. Okay, I'm setting up the devices, I'm bringing up the devices. This is what we did previously. It's only now I have to script this information and maybe use cron jobs. Okay, maybe write some cron jobs, use some to make sure whenever the system reboots, this file get called. This file is ran whenever the system reboot with cron jobs, and then in that case I have this particular namespace that won't disappear just like that. So at this stage I will just go ahead and hit Ctrl O and Ctrl X. You might consider to change the mode, actually change mode to executable, so you can make sure it's always executable. And then what we need to do now is just sh and then the name of the file, and then voila. So now if we run our previous command, let's just go here, we should see net. Okay, so we see now we have got those two namespaces there. Okay, so they have been mounted. They're right there. This is where they're actually mounted. Okay, so we have them there. And now if we list, we get the namespace there. So now I can I should be able to get the status of this one I've configured. Alright, so now if we do IP route list on this particular namespace, we will see the following. We have got our default gateway there, and we have these particular networks that this particular namespace knows about. And if we do the same command, IP route list on the global, we see we have got this particular IP address which we have configured previously using Kuaga, thanks to Zebra Daemon there. And of course we also see these particular networks that our global knows about it. Okay, so this is interesting. So from this namespace, let's go ahead and try to ping something that is outside. So I will try to ping 192.168.10.30. This is one of the IP address within my private cloud. It's failing, and let me try to ping. Let's try to ping 42 network. So we have got a 42 network here. 35 should be up. So let's try that one, and it's failing. All right. So now let's try the public cloud. Let's try the internet. Let's try 4.2.2.2 for that case. It's also failing. Now, if you recall earlier, this has to do with, of course, the masquerading issues. So we need to fix our firewall. Okay. So the way that we will do it. So nano etc show wall. Let me just share with you some files that we need to take into consideration. Again, for the zones, I just defined 2 zones there, and for the interface, this time around I've defined 2 interfaces there, bridge 1 and bridge 2, because what I want exactly is this. I want traffic from, if I can draw it for you. Eventually what we want is traffic from this particular namespace should actually go out using this particular range of IP address and out to the internet. And the same applies to this namespace down here. What we want to do at the end of the day is this particular namespace should use this particular IP address range to go outside to the internet. Okay, this is really what we want to implement right now. So no wonder if you take a look at these particular settings here for the interface, if I share with you. So we have brought I just brought the bridge 1 and bridge 2 onto the local there. Okay, and the other file that might be of interest to us is the masquerade. So I have said everything from bridge 1 should, all the IP address from bridge 1 should change to IP address of bridge 0, and the same applies to IP address of bridge 2 should change to that one. Okay, and for the police, this is gonna be interesting. For the police, I'm using the very interesting police of mine that accepts everything from everywhere. That's a little bit, what should I say? Anyway, that's what's up. And last but not least, let's take a look at the shoal.com file, because here what we have, what I have done here is actually add one more keyword, which is this one, add IP address alias to yes. And previously on the previous configuration I did not have this one, and I also went ahead and enabled P forwarding, of course. So if we do show start, or let's do show check. Okay, we see no errors. Now we can attempt to start our show, and voila. So if we do vtysh show IP forward, we see IP forward is on. I will exit out. Now let's go ahead and onto our namespace there and verify that we can ping the internet. Yes, and if we can ping the global IP address, we should also the global IP address, we should also be able to ping our local cloud here. So 10.30, this one we could not reach previously, now we can reach it. And let me see which let's also try to ping 42.35, I believe. Is it 35? Let me just confirm this particular IP address is 192.168.42. Oh, this is 33, so it's 35. Alright, so we can reach that IP address there. It was my problem there. I mistyped the IP address. No wonder it was this IP address is not in the network 33, but I meant 35. But you get the point anyway. So everything works fine here. We can try the same thing with a second namespace. So we should be able to reach that network. We should be able to reach this particular network. We should be able to reach the internet 4.2.2.2. Alright, so we can reach the internet as well. That's cool. Alright, so far so good. At least from let's do this. At least from this side, okay. From this side things are working. Now we need to tackle let me change the color to make things more clear for you. I need to pick up a color. Okay. Alright, so right now what we need to do is actual no, that was wrong there. What we need to do is this following. So we have this namespace here, okay, this network down here. We need to give it access to the world, to the public cloud and to the private cloud. That's what I meant when I said access to the world, but it's just a private cloud and public cloud. And by private cloud, public cloud, I mean internet, and private cloud, I mean the local cloud. All right. So that's what we need to do. Okay. I will go. Let me launch this. Okay. What I need to do now, since here there could be X number of hosts, here we could have X number of hosts, and down here we could have X number of hosts. Logically, it doesn't make sense to use a static IP address. Well, we could use static IP address, but imagine in a situation whereby we have X number of hosts. So I will. We need to configure DHCP. So let's go ahead and do that. Nano etc. I'll show you how we can tackle this. etc DHCP. All right, DHCP DHCP.conf. This is the file. All right, so we just need to enable some few settings here. I will go all the way down to enable this. This is just going to be your example, and this again is for tenant 1. Alright, so for the tenant 1, I am enable this particular setting. So I will define I have defined here VLAN 10. Alright, so VLAN 10, I've specified the range there, the subnet, so you can start with the subnet. Net mask is the range there. The root, of course, I'm defining DNS because I have DNS internal and the time to live and all that. So the same applies to VLAN 20. Alright, so this is what I've just done on this particular file. Okay, so I will exit out of this particular file. Now to enable this particular DHCP server, you will think like I will have to go to the global. If I enable it on the global, if I do the following, if I say etc init-d ISC DHCP server start, this is gonna back at me. Look, watch this. This is gonna do something interesting. Yeah, it's failing. Now the reason why this is happening, it's because I don't have VLAN VLAN 10 and 20. I do ifconfig right here. Okay. You see anywhere I have VLAN 10 and 20? Huh? No. Yes, no. No VLAN 10 and 20. So that means I will have to go all the way to the namespace that I want to turn on this particular DHCP, etc init-d is DHCP server, and then I'll say start, because the DHCP server actually is aware of the namespace. Alright, so I will just go ahead and say start from here, and this will work because of course we do have those particular VLAN in place on this particular namespace. Now if you are new to the namespace and stuff, it's because namespace, the way the work is, the actual you will need to make directory in etc net names. Alright, you will need to make a directory here, so in this case it will be net1. Alright, and then you also need to do it for net2. Okay, and the reason why we are doing that is because some applications, they are not aware. Some applications, they tend to look for the configuration file in this place. Okay, so in etc net ns, so they will look for the configuration here on a respective namespace, and then if they don't find any configuration there, then they will default to the etc. So no wonder we need to do that. Okay, alright, so it will become quite obvious a little bit later, but for now just take that into your brain. Okay, so now let's go ahead and test our clients to see if the DHCP is really operational. So I will go ahead here to the DNS3 and power up this particular clients of mine. So I will okay, I will start this particular VM, and I will also go ahead and boot this particular VM. Alright, so I have got two VMs that are coming up. Remember, now we are testing DHCP functionality. Okay, so I have got two VMs. VM1 is right there. Okay, it's up now. I will log in as root. I will specify the password there, and I'll do ifconfig, and we see we have got an IP address there. So I will let's try to ping 10.1.1.252. alright, this works. Let's try to ping 10, let's try to ping 192. No, this will not work because of the firewall, but let's just try .30 for instance. Okay, this fails. We cannot ping that IP address. Now we will need to fix that. That's because of the firewall, but at least we know our DHCP works. Let's see if this guy has managed to get the IP address. So we authenticate here by supplying a password, and then of course if I do ifconfig, we see we have got an IP address. So ping 20.1.1.252. alright, we can reach that one. What about ping of 10.252? Yes, we can reach that. And what was the, I think the IP address was .50. Was it 250 on this side? I'm not sure. I think it was just 50. I will confirm. Alright, we can ping this IP address. Alright. Now, probably if you're new to Unix, you might be wondering like, hey, come on, they're sitting on two different VLANs. How come they can ping each other? Well, this is a very interesting feature. It's called the Linux Wiki ES module. Of course, it's well defined in RFC 1122. I give it as a homework for you to go ahead and check it out on RFC 1122. It's quite an interesting feature, ES module. But just to clarify that for you, you know, we have got this particular namespace here. Okay, I will do route -n. Route -n. What do you think? What do you think? We know about this network. I mean, it has to work, right? The way that we are going to tweak this is use, of course, the firewall rules and all that. We can pick this behavior by using the firewall rules. In fact, I'll go ahead and track it a bit later when we start to configure the firewall. But this is very interesting. It's AS module in action there. You can check it again on RFC 1122, right? Alright, so let's just go ahead and proceed. We know things are working here for sure, and we have not enabled the DHCP on this side, so let's just go ahead and try to boot the VMs on this side. So boot VM3 here. It's currently running, it's booting up. Okay, let's go ahead and boot the other VM. This is VM4, VM04. Okay, it's booting. I just want to check out if these guys, for some reason, they're getting an IP address, because there are interesting features here, like the one that we just saw there, the ES module. It might throw you off. Alright, it did throw me off sometime. Alright, so I will authenticate here, and right here I will do ifconfig, and yeah, that's excellent. We don't have an IP address assigned onto the interface. That's what's up. That's cool. And if you're wondering if we are running any DHCP there, etc network interface, this should reveal like DHCP is enabled, but for some reason, which the very good reasons, because we are not running DHCP server on this particular namespace down here, which makes it reasonable for these two devices to come up without IP address. Alright, so let's go back. Did I confirm? I did confirm on no, not yet. So let's go ahead and confirm with this particular VM as well. So I will log in, I will specify my password there, and if we do the same command, ifconfig, yes, we see we have got no IP address on that particular interface there. So this namespace here doesn't have IP address. Now let's go ahead and before I'm caught in a web of confusion, should we proceed with DHCP, or should we go for the show wall configuration? What do you think? Okay, so alright, okay, we proceed with DHCP. This is the one DHCP. Okay, so now for the DHCP on this side, what I will do is, you remember we download this, what did we download previously? Was DNS master, and they said we did not configure this file, right? So let's go ahead and tackle that. Okay, so now what I'm doing here, port 0, I am 0. You can just read this. I mean, this is very easy to configure this. I don't need to go through all this process. I'll just show you what I've did. But here is just to, you know, I'm turning off this. That's what I've done. And let me just share with you some of the stuff that I did here. And I defined the interface here. So I've defined interface VLAN 30 and VLAN 40, of course. And I went ahead and specify the DHCP range. I specify the DHCP range right here. You see DHCP range for VLAN 10 and VLAN 30 right there. Okay, so I did that. That's what I did. Alright, and then let's go down. I did some other stuff which I don't remember on top of my head. Let's share. Let's take a look. Okay. This is very straightforward file once again. I cannot go through all of it, but you will need to read at your own leisure. Okay, so here I have defined the DNS servers. Okay, and that's basically it. That's what I've done. So you should be able to start this particular. You can just go to etc init and say start. Okay, let me just issue a restart here. Okay, so now if we go back to I will come back here. I will power off this particular VMs, and I will power them back on. You really don't have to do this. You don't have to power off and power on the VM for this to work, take effect. It will just take effect automatically, but that's me. Okay, so the VMs are coming up. So let's see if VM3 should be up. VM3, yes, VM3 is up. Let's log in now. I will specify password to authenticate here. Bam! Now we see we have got our IP address there. All right. So this is interesting. And cat etc resolve.conf, we have a DHCP there. Okay, sorry, DNS. Okay, all right, now let's try basic ping 192.168.10.30. This doesn't work because of the firewall issues. 10.1.1.252, this should work. And of course at 20 of 252, this should also work. Interesting. Alright, so everything works here. And what was the IP address on this side? I forgot that. Okay, so at 87. Alright, so let's go back to this guy here and confirm the settings root. I'll specify password. I'll do ifconfig. And this side we have 98, so we can ping 10.1.1.87. That was it 87? Okay, in fact I'm pinging the wrong IP address. 10, what am I doing? 10.1.1.87. Yes, we can ping that IP address, of course. Alright, thanks to the ES module in action there once again. Alright, so things are working here. Let's try. I keep on forgetting these IP addresses. I need to check the IP address of VM1. That was VM1. It was 50. Let's try from here to ping 50. Okay, ping 10.1.1.50. This should fail. Alright, so let's try. Okay, and that really fails. And this is not a bug. This is a good bug. Okay, it might be a bug, but it's a good bug. This is what we were expecting. We were expecting this one to fail, and thanks, it did fail. That's excellent. That's awesome there. Alright, so we cannot reach that particular, because again this is because they're real simple. We don't have a route back to there, so that's cool. It's it makes sense for it to fail there. That's super. Okay, so now what we need to do is go ahead and open up our firewall. Alright, for these particular tenants. Now we know everything is working fine. So for the tenants, so that their hosts go the hosts here go out to the internet as I described earlier, let's go ahead and work that. So this is where I will need to go now. For instance, if I go to etc net names and ns net this is net 2 for instance. Let's go to net 2. Let's start with net 1. Doesn't really make any difference, but I would like to show you on this. I will need to go to nano etc net names net 1, okay, and then show all. First thing first, what you'll need to do here is actually go ahead and copy the show.conf file onto this particular namespace. Okay, so show.conf, this is the particular file that I'm talking about. You need to copy this file over, and once you copy this file over, I mean, again, it's the same settings that I have, it's just copy and paste. That's what's up on this particular namespace, and also the second namespace I have the same configuration. Alright, so it's the same file that was copied over, and also you will need to define your zones. Just as like this. Now here I went ahead and specify the namespace. You can see here for the, this is where I say the local zone. I mean, the zone can be any name that makes sense to you. So here I went ahead and changed it to the specific, the respective namespace. That's what's up. And we can let's take a look at the other one. You see, it's the same stuff that I've done there. And now we can take a look at zones interface. Alright, the interface, I've defined those interface there, as you can see here. For my this is like my local zone now. This is my local zone. Alright, and the same applies to the second one. Okay, let me just share this information with you. Alright, so here we see we have got that one as well. So it's happening, right? And of course for the global, you see this tap interface here. That's what I've defined. Alright, and for the masquerade, let's do the police. For the police, I have this interesting police of mine. This makes me feel like I don't know, maybe like Batman or something. Alright, now here, this is where we go with it. I have those particular VLANs there for the masquerade, so I'm saying VLAN to tab 2 and stuff like that. So this is very clear, this is very obvious. Alright, so here I will go ahead and do show all, check. Alright, so everything works fine there. Then I can proceed to start. I'll start show all there, and let's do for the second namespace. I have started the show all there as well. So now if we go back to our clients, they should be able to ping. Yes, that works. Alright, and they should. So I will clear the screen here. I will ping the local cloud now. I'll ping this particular IP address. This is the 30, and this works quite well. We can ping that IP address. Let's try to ping 42.35, that is. Alright, so this is another IP address, another client of mine within my local cloud. Okay, my private cloud. Alright, so let's go ahead and ping the internet. Okay, the public cloud, that is. And wow, things are working there. Great stuff. Alright, so this particular host can ping all of those IP addresses then, which is cool. Let's go ahead and take a look at VM 42. So I'll clear the screen again and try to ping. I will just do some basic ping of the path. So I'll ping this 30. Okay, so that works, and then I will ping, that was 42.35. okay, so in fact that's not 42, that's 142, so 42.35. alright, so that works, great stuff. And then I will also try to ping the internet. Alright, that's cool. So far so good. What we have done is essential have traffic. If I can share this with you, we do have traffic that is currently flowing through this direction, okay, all the way to the internet and private clouds there. That part works great. And in fact for both tenants as it stands, so we have traffic going through this direction. This traffic now works without any problems. What we need to do at this stage is go ahead and have traffic open some ports so that traffic can also come inside here to these particular tenants from outside. Outside meaning being the internet or the public cloud, the private cloud, that is. So we need to see how we can let the traffic in from the private cloud, public cloud, right? And in fact that really applies for both sides, right? As some other people that would like to call it you find some other people call it destination NAT, and the other people will call it port forwarding, whatever you want to call it. But that's the feature that I want to show you, how we can open this particular traffic up so that user from outside they can have access inside. And I will assume again maybe we are running some web servers, maybe it's a mail server and all that, and we have clients that are sitting from outside that they should have access to these web servers that they're running down here. How we gonna do about it? That's what we're gonna go and work it out, without forgetting the cool, interesting feature that we have seen of ES module. We want to go ahead and tweak that a bit to work more within our favor, because the current behavior really is it's a little bit scary, especially if you are coming from the world that is not of Unix. But if you're from the world of Unix as I am, wow, it's quite interesting feature, and we'll see how we're gonna tweak up. We're gonna tweak it up. And if you want to know more about this particular feature, just go ahead and research the RFC 1122. I love this stuff. Alright, let's get back at it and take a look at how we can customize the Linux Wiki ES module to dance on our favor. What am I talking about? Let's go ahead and examine the routing on net namespace 1, the net 1, that is. That's the namespace down here that we see. Alright, so I'm using show routing command here actually to examine this routing here. Okay, so what we see right now is these particular networks that this particular namespace knows about. So our namespace knows about these particular networks here. What we really want to do is make sure there is no communication between 20 network and 10 network. Alright, so this network, they should be separated, even though they are under one namespace, but then they should not be able to communicate. That's what we really want to go ahead and implement at this stage. We want to make sure there is no communication. Once again, we just want to really make sure there is no communication between the 20 network and the 10 network. They should be totally separated from one another. Alright, so to do that, let's just go ahead and jump straight at it and see how we can work that out. Alright, so we'll need to go and examine our zones here. So let's just go ahead and examine our zones. So we see we currently have two zones, the net zone being the abbreviation for the internet, and the net 1 zone, that is for your probably local zone. Alright, your antenna zone. Okay, so that's fine. Let's go ahead and see how we can implement the rules now to actually deny that particular traffic from flowing around. Alright, so this again is what we have here. We have this 10 network. Okay, so this is our namespace here from our zone. Actually, this is our zone here, which we've called the net 1. Alright, so this is our zone, and from this particular zone we are denying this network from getting to reach this particular gateway here. Okay, the 20 network. So the 10 network we are denying from reaching the gateway of 252, and the same applies here on the 20 network. We are denying it from reaching the gateway of 252. Alright, again, the reason why I'm defining the firewall here, if you're brand new to this stuff, is simply because any interface that is actual on the system is regarded as a firewall. No wonder I have to specify here a firewall. Okay, because this interface is actual on the device, on the firewall. Alright, so again here I am doing the same thing, but this time around I'm just dropping the traffic from 10 network to 20 network, and from 20 network to 10 network. It's that simple actually. And again, if you're brand new and you see maybe there's a kind of repetition and all that, is because of the TCP IP three-way handshake. Okay, alright, so I'll go ahead and save this particular file and exit out from here. What we need to do now is go ahead and restart our show wall process on this particular namespace. So I'll go ahead and say restart. Alright, so now that we have restarted the show wall, we should be able to go back to the respective VMs. I'll clear the process here and get into this particular VM1. I'll do ifconfig just to recap with what we know. Okay, so this is on 10.1.1.50. Let's try to ping our gateway 10.1.1.252. Alright, the gateway works, and let's just ping something outside there. Okay, just 192.168.10.30. let's try that. Okay, that works. Now let's try to ping 20.1.1.252. Alright, that fails. That means our rules stay in place. That's cool. And let's try to ping. The other side was 50, right? That fails. Let me just go ahead and bring in VM2. If I can get to VM2, I'll clear the screen here and ping. Okay, let's do ifconfig first to confirm the IP address on this interface. Okay, so it's 50, so we are pinging the correct IP address down here, and it's failing because of those rules in place there. So I'll ping 20.1.1.50. I'm pinging the interface itself, so that works great. And what about if I try to ping the gateway? Okay, that is 252. That works great. And now let's go ahead and ping the gateway on the 10 network that we have denied access. That's marvelous. Alright, let's do the same thing for that particular host, which is VM1, the host down. We'll do this. Okay, so this is 1.50, right? Okay, so we cannot ping that particular host. That's the host down here. So we have correctly segmented our network. The 10 network and the 20 network, they are complete. They cannot talk to each other right now. So that's brilliant. Whoa. And we can go ahead and do the same thing for the second namespace, that is. So if I go ahead here to the second namespace, alright, so this is namespace 2, and this is the second namespace, right? And we are doing the same thing here. Okay, so that's what's up. And once we do that, of course, the next thing you need is just go ahead and restart the show all process and hope for the best. If we come, let's go to VM3. I will clear the screen here and ifconfig. Alright, we see we are on 87. We should be able to ping 10.1.1.10.30. 10.1.1.1.252. Alright, that's our default gateway. And what about 20.252? Let's do that. 20.252, that fails. That's alright, that's what we were expecting. And let me go into VM4, clear the screen, ifconfig. I don't remember what IP address we have. We have that particular IP address there. Ping 10.1.1.252. This fails, and that's excellent. And the ping of 20.252, that works, and the ping of 10.87, that was, this should fail. Alright, that's brilliant. So far so good. We have managed to do that. Let's proceed now with more interesting stuff as far as tweaking our traffic is concerned. Alright, now what we need to do is open up some traffic. Okay, traffic from outside should be able to reach our internal VMs, which they are on their respective namespace. Okay, I will let's just zoom in here quickly. What we really need to do is, if you go up here, I need to make sure we open up traffic, okay, for www traffic. Okay, so people from outside, okay, people from outside meaning the internet, the internal cloud and all that, they should be able now to come in and access some of the web server that are down here. So we will assume on this particular VMs, let's say VM3, VM4, VM1, VM2, on these respectively namespace, they have got web server that they're running. Okay, they're all running some web servers. What we need to do now is we have access to the outside world. These VMs, they can communicate with the outside world. What if we wanted people now to come in and access maybe our web server and all that? Let's just go ahead and see how we can implement that. Now, to implement that, if you take a look at this particular subnet here, this was I subnetted this. I took this particular, so I used this particular range of IP address for the whole purpose of trying to demonstrate things around here. In a real world, these IP address would have been routable, but in the world that I am in, which is a lab environment, these IP address, they are local IP address, they are not routable. Nobody knows about these particular networks, the internal networks. So one way that I will mimic the real world, if you may, the enterprise world, the service provider world, is go ahead and create some routing here. I will in fact need to go ahead and create routing. Yes, I will need to do routing so that the rest of my cloud knows about this particular network here. So they know about this network, they know about this network, or they know about this subnet, and they know about that particular subnet. Okay, so that's the first thing that we need to do. Once this particular subnet is known to the rest of my cloud, and then we will now be able to open things up. I can easily explain that to you if I do the following. I have got a Windows host down here. This host is sitting on, if I do IP config, there are many interfaces down here, but let's just concentrate on this one. You see, okay, so this host is a perfect candidate for this particular example, because he's sitting on 192.168.10 network. With this is the host that we have been trying to ping from time to time. All right, and this is the gateway. Okay, so currently, if we try from this particular host, if I will try to ping, let's do a ping of 148.135.102.1. we see we get destination net unreachable. So this guy doesn't know about that in particular network. And if we try to ping .65, that doesn't work as well. So the assumption here is we cannot even reach the 10. So we really cannot ping anything in relation to this particular network. This network is not known to the 192.168. So somehow we need to make it happen, alright? Because I will not be able to SSH or do anything to this particular host, because once again, if I go back here and try to explain things how I want them to work exactly, is we have this internal IP address here, okay? This will just be internal as internal, but the public IP address, there will be this one. So these are the address that they will give us access at the end of the day to the rest of the world. And in fact, these are the address that give us access to the rest of the world, and the rest of the world, they need to get access into the network via this particular IP address that you see down here. So now, under normal circumstances, you will have got this IP address from your ISP and they will have been routed, but again, on the situation that we are in, we will need to do tweak things around, okay, to make it happen. So let's just go ahead and make it happen. All right, so let me grab my screen here, my section here. So most definitely, if we do show, let's do IP route list. Okay, we know this is our default gateway. Okay, we have a default gateway of that one, and this is our network. Okay, so this is not a really good candidate for what I'm trying to do. Instead, we need to exit out of this particular system altogether and come here to the gateway. The gateway, this if we do show route -n here, let's see. Okay, so this is our default gateway. So we'll assume this being our higher ISP, okay, and these are the current network that we know about. So we have this particular network and this particular network, which gets us to the ISP, gets us to the rest of the world. What we need to do is exchange routes between us, okay, and the service provider, the ISP, and but the routes that we need to exchange, we don't know, they're not here. It's we really don't know anything about 148. We don't know anything about this particular networks down here. So first thing first, let's start from that end, because we will need to know about this particular network. And then once we know about this particular network, once our system has learned about these particular networks down here, and then they can easily send it to the rest of the cloud, meaning to the ISP and the ISPs and all that, and then things works brilliantly. So let's go ahead and first of all make sure these guys know about the 148.135 network, okay? That is a /24 network that I've submitted. Okay, so to do that, I will essentially need to do the following. Okay, to do that, I will need to do the following. You will need to go ahead and enable Quagga. You have seen me working around with Quagga, so this time around, just, you know, I think this video has been very long, so I will minimize some time here of not going through the Quagga setup and configuration. But there is one thing that is going to be different here. etc Quagga, if we look at the daemons here, okay, so let's go ahead and take a look at the daemons here. This is what I will need to do. I will enable the zebra daemon, okay, this is what I'll do. I will also enable the BGP daemon, and maybe for the future usage and all that, I will enable S50. Okay, so these are the three daemons that I have enabled, okay, and things will come clear once we are done with this. Alright, and to make sure you don't get lost or anything, here are the just simple commands that I did, okay. so you can just follow along there. I will now restart this. Okay, I will exit out. Okay, I will go back in, and that's I'm just, the reason why I'm exiting out is simply so that the environment variable takes place. Otherwise I will have some issues once I log in there. So I'll specify password here, and now we can go straight at it right here. Okay, so this is what we have so far, and actually if we do show run config, we see it's just a default configuration, and there is nothing there. It's just this is the default setting that the system just took it from the configuration file. So we will need to go ahead and change this, because everything now is actual at the kernel level. Here we did not see even the default routing. So if I do route r-n, we see everything. This is from the kernel level. If we take a look at nano etc network interfaces, this is everything comes from here, the default gateway and all that, and include the in relation with if we do IP tables and then do IP tables list. Okay, so we see these are the particular IP tables that we have at this stage. Okay, and let's do table NAT, because that's what we are doing, and we have a NAT table that's there. So this is basically, this is what is happening at this stage. There's nothing much. It's only mainly this is done by IP tables. So okay, everything is through the firewall. So now I will go ahead to the config. I need to do config terminal. Alright, I will start with IP route. So run IP route. I'll send I'll do some default route here, everything to 192.168.10.252. okay, so that one. And now I need to, I don't know about 148. So if I say we really don't know about 148, so we need to create a route so that we know about. Actually, before I create this particular route, let me exit out and show you something. If I, okay, I've saved that, show run config. Now we see we have got a default route there. If I ping 148.135.102.1, this doesn't work, okay, because we don't know anything about it. In fact, it's sending us the default gateway. Okay, that's marvelous, interesting. So we need to change that particular behavior. Okay, so I'll go to configure terminal. Alright, now we need to create a route here, IP route, and I will need to inform this particular system of ours, this particular gateway that we're trying to configure here. I will inform it about the availability of these networks here. In fact, this is a /24, and I will say, if you want to reach those particular networks, please go to this IP address. Okay, so this is what I'm doing. Okay, and I will exit from here. I will save. Now let's try to ping. Yeah, that works now. Okay, so now the other thing that we need to do is currently, as it stands, the interface, we are not taking care of the interface. The interface are being handled by the kernel. Let's go ahead and change that. Okay, so I'll do configure terminal, and I'll say interface. You saw me doing this previously, but well, it doesn't hurt. Okay, the more you see me doing, and the more you do it yourself. Internet cloud. I cannot I cannot talk and write, yeah, at the same time. Okay, interesting. Okay, so IP address, it's 192.168.10.210. This is IP address, and that was /24. Okay, and link detect, of course, and exit. Let's do the other interface. This was ETH1 now. Okay, description, I will say this is 1FR1. okay, and IP address here, IP address, I will say this is 172.16.0.1/30. Alright, and I'll say link detect. Okay, marvelous, we have accomplished that. Now the interesting part is the rest of my network needs to know about this particular network here. So how do I go about doing that? Okay, I will start with creating an access list. Okay, so because this network needs to be, it's let's do show running config, and let's just see what we know so far. So far we have configure our interface. That's super. We have we'll come back to this later. We have these default routes. Okay, so now I will create an access list. Okay, I'll create an access list. I'll call this access list 10. Okay, I will put some remarks on this one because you can do that. I'll say permit. What do we need to permit? We are permitting the tenants. Permit tenants. Okay, tenants. So tenants, if I can say that, permit tenants. Okay, so permit tenants like this. Okay, and access list 10. I will also say permit. Now we are permitting 148. Okay, it will be very clear very soon. 148.135. I want to permit 102.0 actually. Okay, so I am permitting that 0.0.0.255. okay, /24, that is. Alright, so this is my access list. This access list permit this particular network. Okay, and I will follow it up with a roadmap. And the reason why I need to follow it up with a roadmap is because I will use BGP actually when communicating to my ISP. Alright, and my ISP is at 252 when I communicate to this one, because I'm sending these routes now to my ISP, so that the rest of the cloud will know about this particular network, which so far they don't know about it. Okay, that's the reason why I'm doing what I'm doing. So I started with creating an access list. This particular access list permits this particular network. Now I'm going to follow it up with a roadmap. Everything will be clear in a minute. Okay, so I'll create a roadmap. Okay, and this roadmap I'll call it tenants. Let's call it tenants. Okay, tenants. I'll call it tenants. Okay, let's call it tenants root. How about that? Tenants root. And I'll say permit. Okay, permit. Let's go with, that was 10. Now this is 20. Permit 20. And I'll say match. Okay, match IP address. IP address found in access list 10. You see this particular access list down here. It was access list 10. Alright, so that's what we are doing. And I will set a metric, because I'll be using BGP of 30, and I will also set origin this time around of IGP. Okay, and I don't want to have that funny origin of question mark or something, so that's why I'm sending this particular origin there. Okay, if you have worked with BGP, you should know what I mean there. but that's fine. Alright, so I will exit out. I will in fact, while I'm here, I will do interface loopback. Okay, interface loopback, and I will set an IP address. I want this to be 20.20.20.20 and /32. I will exit. Now I'll go to the BGP session. Alright, as we go into the BGP session, there is one catch to this and I made it actual so that you see how some stuff that can be actually customized within a favor. What we have is actual, you see here by default, when you copy that particular file, it will create this autonomous number for your BGP, the 67675, but and then our BGP, our router BGP, we want to be the autonomous system that we want actual for this particular gateway is 7475 actually, instead of 7675. So let's go ahead and examine how we can change that. So I'll save this particular configuration here. I will exit out. I will go to nano etc and then Quagga. I will do quagga.conf right here. Now this, to remember again, this was the main file that was we used to write, and here are somewhere here, right here, we see we have got this particular BGP route ID, sorry, the BGP autonomous system, which is 7675. What we want is 7475, so I'll change it from there, and then Control O, and then Control X. Now this, in order for this to take place, I will need to restart Quagga. So restart. Alright, so this is going to restart Quagga. Now I'll go back. Otherwise I'll go to show running config. This will show us the running configuration, and instantly see that 7475 has changed, and also the route ID has changed. So now I can go to config terminal, alright, and go to router BGP 7475. okay, and now once I am here, I will need to, okay, now once that I'm here, I will start by specifying my neighbors. So I'll start with the neighbor statement. So I'll say neighbor 192.168.10.252. This is my neighbor, and the remote AES for this particular neighbor is 150. You should have some information as regards to your neighbor. Okay, so I will say 192.168.10.252. this is my neighbor again. I will set a description here as ISP1. okay, alright, now I will do the same thing for this particular neighbor, but this time around I see here for the information that I have, we do have a password, okay, and that particular password is, okay, I'm trying to, okay, open lock, okay, so that's the password, that's the password. Let me just confirm this password, okay, just a second. Alright, I just had to confirm that particular password there on there. So we have that particular password, okay. So this is interesting. So far so good. We have managed to set up our neighbors and all that. We have the we see we have here the BGP route ID was created for us automatically. Okay, so now we need to do redistribute. This is where redistribute. We need to redistribute static. Alright, static route map. Alright, what was the name of the here? The name of the, it was this one. Okay, so it's a copy paste. Alright, tenant routes. So that's what's up. Okay, that's what's up. Now I will exit out. And I will save this. Now if we do show BGP summary, show. Okay, so now we see. Okay, that's cool. Now on our host, if we bring if I can bring my Windows host, we should be able to ping this IP address. That works. Okay, that's fine. So far so good. Now we are able to communicate, and everything works fine there. So our configuration work. Alright, unfortunately this lab doesn't take you to the ISP side of things. Okay, so I cannot I will not be able to show the other side as what's really happening there, but you see it's working, so that means we can communicate to that side. And if we do show IP route at this stage, okay, so we see nothing much, because that guy is we are not they're not sending us any BGP routes. We are the ones who are sending the BGP routes to the ISP. So that's what's up. Okay, that's normal. Alright, so I'll exit out of here, and now we come to the cool part, which is to let the traffic flow inward. Okay, so I will come down to my host. If I can, let's try to examine our host and see what we know. I will this is okay, I will clear the screen here and do ifconfig for this particular host. So okay, we have an IP address of 10.1.1.87 there, and let's take a look at namespace. So I need to SSH to 172.16.0.2. Alright, I'll specify password. Okay, so in this particular namespace I'll do ifconfig. Now, okay, this is excellent. I did this intentional. You see this particular tab here, it has got this particular IP address. Let's bring our Windows client and see if we can ping that IP address there. That is 80. Okay, we can successfully ping that IP address from outside. What I want us to do at this stage is essential. If I can bring this one. Okay, let me try to make things clear here. Okay, what we want to do is we have got a .80 IP address. Okay, we have got a .8 IP address somewhere here. So we have an 80 one from this particular network, but with 80. Okay, if I can draw on the screen. That's not funny. Anyway, what we really want to do is, since we have got this particular IP address here, this IP address should respond to this particular VM down here. So we want this particular VM, which is currently on 87. From the outside, from inside is 10.1.1.87, but from the outside we want it to be known as 148.135.102.80. Alright, so if somebody is opening their web browser and type 148.135.102 calling port 80, they should be directed to this particular box down here. If they want to have an SSH session, that SSH session, when they open the SSH session and type this particular IP address 148.105.80, and then exactly they should be brought to this particular VM down here. This is what we want to do. Okay, as complex as it might sound, I hope not that complex, although it's very simple, because the way that we are going to do it is again go ahead and use rules in order to achieve this. So I'll go ahead and show you exactly what we're gonna do. So I will open up the rules files on this particular namespace where I want to make the changes in, and then once I'm here I will define the following rule. Okay, alright, so this is my destination, my DNAT rule, my destination rule that I am setting up. You see from the net, I'm defining here from the net, and this is the zone, this is net 2, and I am saying this particular IP address, this is the port, okay, and that is the IP address that we want to masquerade or to change. Okay, alright, so once we see everything is fine there, we can just go ahead and now we should be able to do show all check. Okay, we see no errors. Always whenever you do this kind of changes, it doesn't have to do show all check, so you can check that, and then once you see everything is fine, and then you can issue a restart. Okay, and hope for the best. So we are restarting, and now if we go back to our client, if I can bring my client here. Alright, so this was up. I will test the ping functionality. Okay, so that IP address works, that we can ping it. That's super. Now I need to bring in let me just see if I can grab browser here. So I'll bring a browser into the state here. Okay, so we wanted 148.8. okay, that's the IP address that we are looking for, and okay, so it works. Alright, so this is brilliant. Now we have a web server running, so you will need to do the same thing. You can get a web server or something that you can always test. You remember on the beginning of this session I showed you how to install, what was that? DNS mask, and that was simply to show you it's possible to install other applications. Okay, to justify that I went ahead and installed a web server on this particular VM, and as you can see it's working fine. Alright, so let's say we want to SSH. Let's test the SSH from outside. Okay, so I will see if we can SSH from this side here. Okay, the IP address that we want is 148.135.102.80. okay, this should not work. Under normal circumstances it should not work. Alright, that's what's up. It doesn't work, and the reason why it doesn't work is we need to define this. Okay, so taking a look at these particular rules that we created somewhere here, you see there is we only allowed TCP port 80. That was the protocol that we allowed, okay, for this particular IP address to masquerade, or the destination at the port forwarding, however you want to call it. So if you take a look, before we tackle that, I need to show you something which I think it's important. If I go to nano etc services, here we see a list of ports that they are actually being assigned by IANA. So you can take a look here of all these different ports, and then that you can always implement within your environment. I mean, you don't have sometimes to remember these ports on top of your head. I mean, there are many things to remember, so you can just take a look of it right here. Okay, you don't have to memorize this. So I will go back to my rules. Okay, and for this we need to open port. What port do we need to open? We need to open port 22. Alright. Alright, to open port 22, this is exactly the same thing. It's the same methodology, the same structure that we have used above there. The only difference here is I have just gone ahead and add port 22 this time around, and that's for SSH. Alright, so let's go ahead and save this particular file, and then we will need to restart show all. But before we restart show all, let's just go ahead and check to see whether that was a correct syntax. Okay, so we have correct syntax within our files. Now we can attempt to restart and hope for the best. Now we go back to our Windows session. Okay, let's go back to this particular client down here. Alright, so we can restart here. Let's try this. Alright, so brilliant. Now this works, so let's save this, and I will specify user root and password. Okay, now we are in. Excellent. So we see everything works really absolutely brilliant, and now we are able to log in from remote. Now you can just go ahead and do some other interesting stuff, because it doesn't get cooler than this, does it? Alright, so now we can proceed with more interesting stuff. And talking of interesting stuff, now let's examine our situation. Our current situation is what exactly we are doing, because we have been spending a lot of time with network function visualization. Alright, we have done a lot with that. Okay, so now let's see how we're gonna go ahead and tackle SDN. Alright, so let's now go ahead and do some paradigm shift here, and instead of thinking outside of the box as we have been doing, let's think as if there is no box exists. Let's take a look at the big picture. And what do I mean when I say let's take a look at the big picture? Alright, so this is what I mean exactly. Currently we have been working around here. Okay, let's assume like we have got these VMs right here. They are not really actual VMs, but rather they are physical devices. Okay, and we will assume these particular physical devices. Let's say this is net 1. On this particular rack, maybe they're connected somewhere here, and we have this one connected somewhere here, or somewhere there, and maybe the net 1 tenant occupies all of this space on the rack. So all these devices that you see here from there all the way down, they maybe belong to this particular tenant. Okay, that's what's up. Now the same applies to the second tenant, which is this one. So we have maybe this device connected down up there, and this device may be connected somewhere up here, and maybe they occupy all of this space on the rack. Okay, now, and when it comes to this particular device down here, this particular switch here, this particular switch, the way that we have set up this switch is simply to mimic this particular device here. Right, so we have got 24 ports, out of which 24 physical ports, that is, out of which 5 ports they have already been used. We have connected to this particular gateway, and we have connected to this particular host down here. Alright, and on top of that, we have created 4 virtual switch, that is bridge 0, bridge 1, bridge 2, and bridge S0. Alright, now the way that our currently our currently switch they behave, the switch that we have went ahead and programmed, the way that they behave at this stage is they just simply floats packet received from a port to all other port, so they are simply a hub. The problem with this is when you get to 20 or above devices, collision on the network starts to happen. Collision do slow down everything. The modern application of today, for instance, voice over IP, beg your pardon, they cannot tolerate this. Alright? So we need a mechanism to go ahead and change this. One way we could have done this is, you have seen me actually previously going ahead and tweak this particular flows and all that in our favor, but that was a little bit manual. We want to have a centralized device. If I can draw on the screen now, we want to have a centralized device. Let's say we've got this particular device somewhere here. Alright, and to program this particular device here so that it will change the behavior of this particular switch here, okay, without us going to the system and start to tweak the flows in a bit manual, because today we have a network of 4 devices down here. Tomorrow we have a network of 20 devices somewhere here. Well, maybe we have daisy chain this particular switch to another switch and all that. You see where I'm going. The point that I'm trying to make is these networks do grow, and they grow in a very mobile way. They are unpredictable. Today you have 2 devices, tomorrow you have 5 devices, after tomorrow you have no device at all. They just change like that. Now, it would make sense if we have a device that can just go ahead and program this, and whenever change happens, and then this particular device out of the box take care of that. Okay, now the way that we are going to achieve this is using a controller. So this device here is known as a controller. This controller here is going to control this particular behavior of this hub. So we will change that layer 2 hub into a more switching hub. It will learn the MAC address of the host connected to port and returns it in the MAC address table. Okay, when receive a packet address to host already learned, it transfers them to a port connected to the host. When receive a packet address to a non-host, it performs folding. Alright, so at this stage, we, instead of this every single packet, the behavior of a hub is not that fun, but at least the behavior of a switch in combination with VLANs that we are working down here, we should be okay. What do you say? So let's go ahead and take a look at how we're gonna implement this. Alright, as we move towards the configuration of our external controller here, there's one thing that I would like to bring into attention, and that is this particular switch down here. This switch here currently has got a controller that is already installed there. We have got an inbuilt-in controller, which is a POX controller, of course, and that controller supports OpenFlows of version 1.0. Now let me just share with you this particular information here. We currently see we have got a POX controller here. Once again, this particular POX controller has a support of Flows 1.0. What we really want to do is essentially go ahead and use an external controller that we have actually downloaded from sdnhub.org. So we will use the stack of controllers that we've downloaded from sdnhub.org and enable RUI controller there. Okay, from that particular stack we're going to enable RUI controller, and the RUI controller we are going to enable version 1.3 of the flows, and then of course start to configure this particular switch at the end of the day with the flows of 1.3, and the brain will be right here. Okay, so to proceed with that, I will assume at this stage you have already got your controller. As you can see, I have got the controller, and this is again the stack of the controller that was downloaded from sdnhub.org. And the way that I have connected this particular controller now is just use this virtual cable, if you may, and connect it to ETH23 from this controller ETH0. This controller actually I have just assigned one network card, which is ETH0, and it's connected to this particular switch on port 23. Okay, so ETH23 connecting to the controller on ETH0. Alright, so what we need to go, let's just go ahead now and see how we can configure this. So I'll exit out from here. If I do OVS VCTL show, let me just do OVS VCTL show, and we see currently we have got 4 bridge again. Alright, that is bridge 0, bridge 1, bridge 2, and bridge S0. We want to concentrate on bridge S0. Alright, so let's go ahead and see how we're gonna go about it. So first thing first, what I'll do is create a port here, OVS VSCTL. I'll add a port onto bridge S0, and the port that I want to add is tap 0, and I will set the interface of tap 0. I'll set the interface of 0 type to type equals internal. So this will be the interface that will actually be communicating with our controller there. So I have added this particular tap interface for the whole purpose of communicating with our controller there. Alright, so what I'll need to do now is actually configure some IP address on this particular tap interface, as you can imagine. So I will use Quagga for this purpose. So I'll go in and hit configure terminal. I'll say interface, so I will define my tap 0 interface here, and I will say description. I will say description here is anything that is really meaningful to you. I'll say controller. Alright, and that will be my description. And then I will of course specify IP address. Now I want this this interface to have IP address of 12.16.0.1, and that will be /30. Alright, and then I'll say link detect, and then I will exit out. Okay, I will exit out from here, and then I will go ahead and save. I will exit out. Now if I do ifconfig, we see we have got our tap interface here, tap 0. Alright, and we have got these other interfaces, but what is missing here is we don't see ETH23. Alright, so ETH23, that is this particular interface which connects to the controller, it's not here, so that means it will not work. So in order to we need to go ahead and bring up that particular interface. Okay, so I'll say OVS VSCTL. I'll do add port. This time around we are adding port ETH. We are adding onto bridge S0, aka switch 0, port ETH23. So this particular port interface ETH23, we are adding it onto the switch 0. Okay, so now the port, of course, we need to bring up that particular port. Now we can use commands such as OVS. If we say OVS of control, and then we use the mod port command. Okay, and then on switch 0 we say we want to bring ETH23 up. Alright, now if we do ifconfig, we should see we have got that particular port up. Alright, so it's this particular port, and at this stage we should be able to ping 12 1.16.0. The other end I configure it with .2. Okay, so now we can reach the controller. That's fine, but again, there are some few settings that we need to change. If you do obvious off control, and then we dump the flows on this particular switch, okay, say dump flows on this particular bridge, we see we have got the default flows. Okay, what we need is to go ahead and delete these particular flows and enable version 1.3 on this particular interface here, aka switch. Alright, and then proceed. Okay, so one thing at a time. Let's go ahead and delete these particular flows. So let's go ahead and issue a delete. Yeah, so delete the flows. Alright, so now if we dump the flows, we don't see any flows. Alright, we don't have any flows, and if we issue a ping here, this doesn't work now simply because we don't have any flows. Alright, so what we need to do at this particular stage is go ahead and enable the version 1.3 on this particular interface. Okay, and I will quickly do that. So now we have enabled this particular flows of version 1.3, and of course we can dump the information, and we see indeed we have the version 1.3. At this stage we need to set up the controller. Okay, so I will go ahead and define the controller. Alright, I have defined that particular controller there, and if now we dump the flows, we see there is no changes. We just defined the controller, but the controller on the other end, it has not been configured to communicate with this side, so we will need to do that. So if I do obvious VCTL show, we will see we have the controller. You can see the controller is up there, but what's happening is this particular controller is it has not been it's not connected yet. Okay, so the controller has not been connected, so we need to connect this controller, and to do that I will need now to go to the controller. Okay, this is the controller that we've downloaded from SDN hardware, and once I'm here I will list all the directory, and we see we've got several controllers here, but let's just concentrate on the RUI controller, which is this one. This is the one that we want to make use of. Okay, so let's go ahead and CD into the RUI controller. Okay, so I will then do ls-al here. Alright, so we see we have got several applications here, but what we really want is to go ahead and launch the simple switch. Okay, the simple switch, that's what we want to go and launch, and it's of version 1.3. so I'll go ahead and I will just increase a bit the screen real estate so that you see clearly what I'm typing here. Alright, now I will go ahead and launch the controller, and yeah, we see now the controller has actual communicate with our system. If I go back here and bring this one up and show, we should see the controller is now connected. The status is true for connection. Alright, so at this stage we should be able to ping. Let's ping the controller itself, 12.16.0.2, and we see our pings work, so that means everything's working fine, and we should be able to ping 10 from the namespace, that is. So let's just do that quickly. From this particular namespace, we'll try to ping 10.1.1. That was the 87, right? And did I issue ping? let's do ping. I'm too quick sometime. Alright, so that's it. So we can reach that particular IP address, and that means our Windows host should be able to communicate to this particular VM. I will go to the Windows. Okay, so alright. Okay, so I will bring in the Windows host there, and let me launch the browser. Alright, I can launch the browser. Okay, let me bring this to the stage here. Okay, let's just try to load this particular page and see what happens. Okay, so we are able to communicate with that particular, and we should be able to SSH. So let me try to launch an SSH. I will launch an SSH session. Okay, so run. Then I will change the IP address here. Okay, that was 148.135.102.80. Alright, so yeah, we see we are prompted with a login screen. That means everything's fine. So I will log in as user root. I will go ahead and authenticate, of course, and voila, everything works fine here. Okay, so everything works fine. We are able to log into this particular box, and that's brilliant. That's marvelous, excellent. So far so good. We have manager 12 to let's go ahead and dump the flows now. Okay, so I'll go ahead and dump the flows and see what we have. So if we dump the flows, we see we have got all these flows that they have been generated by our controller. So everything works at this stage. We have got our controller up and running, and wow, we are ready to proceed with more interesting stuff. That's brilliant. Most people, they come with a feature that is imposed in them, that is the power of imagination. This is just a feature that is imposed on some people. Unfortunately, there are some people that they don't have this feature for some reason that is beyond my knowledge. But I hope you are one of those people who can imagine. I just hope so, because I really hope so, because otherwise it's going to be very tricky here. Because now we will need to imagine, think outside of the box. So you see Batman there, you're like, okay, so we have to think like Batman? Yeah, maybe when it comes to networking, probably, yeah, we need to do that. And the reason I'm saying we need to do that is because we are sitting in the lab environment, okay? Sitting in the lab environment gives us the privilege to think way above and beyond. What do I mean by that? Okay. We have got a very interesting challenge ahead of us. We have this particular network down here, which we did build it for quite some time. We have been spending a lot of time building this network here. Alright, and we will imagine this is maybe West Coast. Okay, so this will say it's West Coast. Alright, so the West Coast side of things, we were hired to build it and all that, so it's up, it's hunky-dory and all that stuff. It's good, it's ready to go. Alright, now we are in a situation whereby somebody else was hired to build this particular network as well. Same setup as we did on the other end, but it's just somebody maybe was able to do that. Or maybe it's us who did the same thing here again, because the configuration of here and here, they just the same. It's only the IP address and things that has changed. So we'll imagine this to be East Coast, and this again is West Coast. Alright, so we have West Coast and East Coast. What we have here is these particular tenants. You see we have got tenant 1 and tenant 1 over there, tenant 2 and tenant 2 over here. That's perfect. So far so good. What we really want to do is, and that's where the power of imagination comes in, and that's where you really need to be a Batman on this stuff. We want these servers down here, okay? We want this server for this particular tenant down here, to be able to communicate with those servers up there on that particular tenant. Now you are like, okay, are they not doing that because of this particular IP address that we went ahead and set up previously? And I'm talking about this IP address here, by the way. This IP address here, okay, we went and set up this. Yeah, this one, remember, we set it up for the global, so meaning like maybe we have web servers. In fact, we went ahead and installed web servers. So we wanted to have when people there from outside, when they want to come inside, so we just mimic an environment whereby we have these are like public IP address, and we have people from the cloud that they wanted to have access to these web servers of ours that could easily come in. That was the whole purpose of having this particular IP address here. But now things have changed a bit, because this particular IP address that you see down here, we are going to use them so that these server, they somehow synchronize because of high availability. So we say these are web servers, right? Now, in case this site goes down, for some reason this site goes down, users should not be affected. They should still be able to get onto a web server, right? The web server that they always see, they love it, they have bookmark and everything, should always be available. And that's why we went for this east and west at first place. And another thing could be also maybe in west coast we have lots of users, and the east coast we also have lots of users. Now geographically it doesn't make sense for users in the west coast to travel all the way to the east coast while the servers are somewhere here closer. So that's why we brought this service closer to them at first place, right? That's why we brought this closer to them. But again, they need to synchronize. So the information that is available on the server on the east coast, whereby most of the people that they live in the east coast see when they come here, it's the same as the information that these guys on the west coast they see. So the information synchronized. And how are we going to do that? That's where the imagination comes in. So we need to set up our network, right, in such a way that we can synchronize between these IP addresses. They can synchronize these servers down here. Once again, they need to synchronize via this particular IP address. I hope it's clear. So we need to go ahead and implement that feature and see how we can do synchronization. Now, there's one thing that before I go to demo this, I should be very clear. When it comes to synchronization of servers and all that, there's a lot of applications out there that they can help you do this. I am just going to lay up the networking. I will be dealing with the networking part, which will actually help us when we want to do this kind of synchronization. So I won't go into the web servers and try to work out the synchronization, maybe install PC Maker and all that, you know, all these different applications that will assist you. Alright, this is it right now. Our data center is really growing, and now we are going to essentially witness the east-west traffic in action through the power of the Virtual Extensible Local Area Network, aka VXLAN. They are so cool because what they are actually is just an overlay network which transport layer 2 network over an existing layer 3 network. So it's going to be very clear in a moment here when we do go ahead and lab this. But before I go ahead and implement this particular feature, there's one thing that I would like to bring to attention, although I would like to stress the following. There is a lot of tools out there that they might assist you with load balancing and high availability. For instance, with load balancing, you might want to consider Nginx, Pen, Pound, HA proxy, and for the high availability, maybe you might want to consider things like or tools like PC Maker. Now, it's really up to you as how you want to go ahead and do that, and it depends on what applications you want to go ahead and cater for high availability and all that. But once again, this particular session is only to lay the framework, I should say. I will just lay up the framework extension, in fact using this the power of XVLAN. So we're gonna go ahead and see the overlay in actions, how we're gonna do the transport of layer 2 over an existing layer 3. And once again, if you want to go ahead and do some load balancing, it's really up to you. You want to go ahead and do high availability once you've got that framework, and then it's your own creativity behind the scene now to go ahead and make it happen. Alright, now for this particular session, this is what I'm about to do right now. Okay, so let's go ahead. First thing first, as we can see some IP address there. They have labeled the IP address and everything. That's awesome there. So everything here depends much with IP reachability, right? So right now we need to make sure, for instance, we can ping the other side, so if we can ping 120.145.60, no, this should be 70, right? 70. Alright, there we go. So we can ping this one, and then we should be good to go, since we can ping this particular IP address. Alright, so what I'll need to do is just go ahead and say OVS VCTL. Alright, and I'll add a port. Alright, so this port that I'm going to add is on switch 0, and I'll call this VXLAN. Let's do VXLAN 1. Alright, and then I will say set interface. Okay, I'll say set interface VXLAN 1. Alright, I'll say type. Alright, notice the type is very important now, because I'm going to specify VXLAN. You have seen me previously specifying 10, but this time around it's a bit different. I need to increase a bit the resolution here, because I also need to specify here the option. Okay, options. Okay, options remote. Okay, I have to specify the remote. This is where maybe if you are new to this, if you're brand new to this stuff, you might think a little bit weird, because you have to specify the other end. So we have to specify the IP address of that particular side. Okay, it's 145.70. Alright, so once we have this in place, then okay, so here I just because the resolution again is a bit fun on my side here, I need to specify somewhere here. I need to specify the IP. Okay, so remote right here, remote IP equals. Okay, so that should do it. Alright, so now if we do obvious VCTL show, alright, this will show we already have that VXLAN port up there. Alright, so at this stage we should be able to test the effect of this. Okay, so let me go ahead now and locate the boxes that we can test. So I will go ahead and bring VM1 here on the stage. Now at this stage it should be able. Let's see what was this is the other PC that I need to test. Okay, so I will come. Let me locate for that particular PC. It's essential, this one right here. So once I'm here, I'll just do if config. Right, so we see this is the IP address. Okay, it's 10.1.157, and then where did I put the other PC? Okay, so I'll put this one inside a bit. So this is it. So if I do if config here, alright, so this one has got 10.1.150. Okay, so right, let me see if I can fit this thing here. Okay, so I will ping 10.1.1.157, and this works excellent. That's brilliant. And from here I should be able to ping 10.1.1.50, and that's super. So yeah, that's the power of VXLAN, the Virtual Extensible Local Area Network. We have just seen the magic there of transporting a layer 2 network of an existing layer 3. This is so awesome for the east-west traffic. So yeah, alright, the foundation has already been laid. Now it's really up to you to take it to the next level. I hope this has been informative to you, and I'd like to thank you for watching.